Our world has changed so much since I was a kid that things that I want to do now weren't even possible for me to imagine.
I don't even know if I knew it was called computer science or programming.
It all sort of happened by accident.
I was always excited about technology in some way, and people.
And I thought that was just really neat to be able to control the technology instead of just having it control you.
I think a lot of people wake up and they have an amazing idea. When you know how to code, you can go and actually make that a reality.
I'm the Deputy Innovation Officer.
I'm a design lead,
a UI designer,
support engineer, software engineer,
developer programs engineer,
Chief Product and Design Officer.
I'm a VP.
I'm the CEO and founder,
co-founder. I am a coder.
By learning about engineering, computer science, and other technical fields, you can solve the really big problems.
We're trying to do things that could radically improve the world.
Things like transportation and health,
making our cities better places to live and making people more connected.
A place for city kids to build and create.
I created a Moon TV system to project video on the moon.
Computer vision technology.
Open source hardware company.
Measure air pollution with your mobile phone.
I love helping people do the things that they love to do more easily.
I really enjoy the fact that I get energy from so many people.
I just hope that I can see the world change in my lifetime. That inspires me.
So build it around something that you like.
Find something that interests you. What are you passionate about?
Know what's the thing that's going to keep you going.
And you can really have an impact on the world.
Technology brings us closer together, even when we're far apart. Google developer groups host meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDG, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members a lot. So I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to developing the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Bonjour.
Hola, hola.
Привет.
Ciao.
Salam. Namaste.
Hola, ¿qué tal? ¿Cómo estáis?
Assalamu alaikum और खुश आमदीद.
Вітаю.
Bonjour, comment ça va?
Hola.
My name is Kate. I'm from GDSC KPI at Kyiv, Ukraine.
I'm Rubén Aguilera from GDG Madrid in Spain.
I'm Guillaume Blacquier, Google developer expert on Google Cloud, and I'm living in the south of France.
My name is Alina.
Selamat sore dan selamat bergabung dalam Machine Learning Study Jam 20 and 22, kolaborasi dari GDG Surabaya dan GDG Cloud Bandung dan Institut Sains dan Teknologi Terpadu Surabaya. Nah, Study Jam ini merupakan pertemuan final keempat kita setelah 3 kali lalu kita belajar bareng online dan pertemuan pertama kita on-site di Institut Sains dan Teknologi Terpadu Surabaya. Nah, pertama-tama kami mengucapkan selamat datang kepada teman-teman semua yang sudah berkenan bergabung dengan acara webinar kita pada sore hari ini. Nah, perkenalkan saya Dwi Nurul Istiqomah, teman-teman bisa panggil saya Isti. Saya itu dari GDG Cloud Bandung yang akan memandu acara webinar ini selaku Master of Ceremony. Nah, sebelum kita memulai sesi kali ini, saya mengajak teman-teman semua untuk memfollow terlebih dahulu akun Instagram GDG Surabaya dan GDG Cloud Bandung dengan nama akun yang sudah di-share oleh Mbak Jocelyn Nah, itu. Nah, mari teman-teman bisa follow akunnya karena ada challenge menarik nih yang dapat teman-teman ikuti. Nah, syaratnya juga gampang. Nah, teman-teman cukup follow @GDG Surabaya dan GDG Cloud Bandung di Instagram. Nah, jangan lupa untuk tidak memprivate Instagram kalian ya. Nah, setelah itu sampai tanggal 20 Agustus 2022, kalian bisa snap your best moment dan upload momen tersebut dengan Twibbon. Nah, linknya udah di-share juga ya sama mbaknya. Nah, jangan lupa tag Instagram GDG Surabaya dan GDG Bandung supaya kita bisa lihat dan repost kontennya. Nah, semua yang post akan mengikuti lucky draw dan satu orang beruntung akan memenangkan voucher dari tiket.com untuk healing kalian semua. Nah, selain itu ada lucky draw juga untuk peserta yang join minimal 3 sesi termasuk hari ini. Nah, serta banyak hadiah juga dari GITS Indonesia. Nah, cek pengumuman pemenangnya di Instagram GDG Surabaya dan GDG Cloud Bandung. Nah, oke, langsung saja tanpa berlama-lama lagi kita akan masuk sesi pertama dengan judul Time Series. Nah, pada
Recording in
sesi
progress.
ini yang akan memandu yaitu Pak Re dan tim. Nah, Pak Re ini merupakan tim juga dari GDG Cloud Bandung serta CEO of GITS Indonesia dan juga Pak Re ini merupakan dosen dari Universitas Pajajaran. Nah, Pak Re ini juga suka banget diskusi mengenai produk dan project manajemen. Nah, teman-teman boleh banget nih diskusi dengan Pak Re mengenai produk dan project manajemen. Nah, oke, tanpa lama lagi, teman-teman juga perlu ini ya, bisa langsung tanya via chat di Zoom. Nah, karena ini merupakan study jam, jadi sewaktu-waktu bisa bertanya gitu ya. Nanti saya akan membantu menanyakan kepada Pak Re. Nah, baiklah, untuk waktu dan tempat silakan Pak Re.
Oke.
Oke, monggo.
Halo semuanya, salam kenal, saya Ray. Saya izin share screen dulu sebentar ya.
Nah, oke, sambil Pak Re share screen nih, apa kabar Pak Re?
Baik. Alhamdulillah, sore ini Sabtu-Sabtu lumayan ramai ya.
Iya, lumayan ramai.
Kita belajar ML bareng nih dari tanggal 30 Juli ya kalau nggak salah ya, Mbak Esther dan teman-teman GDG Surabaya, GDG Cloud Bandung. Saya udah share screen belum ya?
Masih belum nih Pak Re, masih belum di share screen. Oke. Pak Re di sini bareng beberapa timnya ya, dengan Mas B dan juga Mas.
Oke, udah kelihatan?
Saya dan juga Mbak Jihan. Oke, udah kelihatan Pak Re. Silakan Pak Re dan tim.
Oke. Thank you semuanya. Thank you udah hadir di ML Study Jam yang keempat ini. Dan hari ini kita akan bahas tentang time series dan forecast juga ya. Jadi salah satu yang menarik di time series adalah gimana cara kita memforecast based on waktu besok atau besoknya lagi dan besoknya lagi. Dan seperti tadi dibilang sama Mbak Isti ya dari GDG Cloud Bandung, ini adalah hasil kolaborasi dengan GDG Surabaya. Jadi GDG Surabaya nih, all the hard work, thank you buat Mbak Esther, Mbak Indra, Mas Ian, dan teman-teman Mbak Jocelyn juga yang sudah host ML Study Jam ini dari awal gitu ya. Yang meeting pertama offline dan 2, 3, 4 termasuk hari ini yang keempat itu online. Oke. Ya, seperti ini beda mungkin ya dari yang sebelumnya. Hari ini saya keroyokan, jadi kita bagi tugas semuanya. Saya sendiri perkenalkan sekali lagi, saya sendiri adalah co-lead dari GDG Cloud Bandung. Hari ini ditemani Isti. Biasanya di GDG Cloud Bandung itu ada beberapa orang ya, ada Mas Krisna, ada Mbak Indah juga, ada Mas Farhan, dan ada Mbak Indah dari WTM. Ini kebetulan Mas Farhan dan Mbak Ina ini suami istri ya, kejadian gara-gara GDG Cloud Bandung tuh jadi suami istri dan sekarang lagi persiapan kelahiran Pak ya. Dan hari ini saya bersama Mas B ini adalah CE atau Customer Engineer untuk Cloud and Data di GITS. Ada juga Mas Arya Bagus, ini adalah Data Team Intern di GITS juga. Dan Mbak Jihan dari Data Team Intern GITS juga. Dan Mbak Jihan ini lagi di Bali nih sekarang. Mas Arya sih di Bandung. Oke, langsung aja kita ngobrolin. Hari ini kita akan ngobrolin tentang beberapa agenda. Yang pertama tentang time series itu sendiri dan forecasting, maksudnya apa sih? Terus nanti kita masuk ke yang lebih teoritisnya, modelingnya gimana, konsepnya seperti apa, dan gimana sih cara meng-apply-nya di machine learning. Jadi untuk dua sesi yang pertama, saya dan Mas B mungkin akan bahas tentang basic konsepnya. Nanti kita akan ada live coding juga dari Mas Arya sama Mbak Jihan untuk di Python-nya caranya pakainya gimana. Walaupun sebenarnya MS-ID-nya harusnya pakai Kaggle ya, tapi nanti kita pakai Google Colab biar ngikutin sama sesi-sesi sebelumnya. Oke, jadi mungkin introduction tentang time series juga, time series dulu ya. Jadi time series itu apa sih sebenarnya? Time series itu sebenarnya sebuah kumpulan data atau series of values atau set of data berdasarkan observasi dari waktu ke waktu gitu ya, over period of time. Jadi kita punya sekumpulan data yang biasanya diurutin berdasarkan waktu. Misalnya kita punya data apa namanya, data penjualan. Tiap hari kita punya data penjualan sekian, dan itu dikumpulin berdasarkan dan diurutkan berdasarkan waktu. Di sini di time series ini waktu itu berguna sebagai variabel yang independen untuk melakukan estimasi ke variabel-variabel dependen. Misalnya apa nih? Misalnya kita mau mengukur berapa banyak kebutuhan yang perlu diproduksi gitu ya, demand dan production. Berapa banyak yang akan terjual nanti? Berapa kalau orang yang suka main saham atau stok atau mungkin main kripto juga, berapa sih kira-kira harga aset yang nanti akan kita harus jual, kapan kita harus beli gitu ya. Jadi dapat cuannya yang mantap gitu. Atau kita juga bisa lihat berapa banyak energi digunakan. Misalnya kalau kita kerja di gedung, misalnya di gedung itu dari hari ke hari dia energi use-nya kayak gimana gitu. Jadi itu gunanya time series. Jadi time series ini memang salah satu tools yang paling populer untuk melakukan planning. Jadi kalau kita udah bisa tahu ke belakangnya kayak gimana, kita bisa memplanning ke depannya nanti berapa yang harus kita produksi, atau misalnya kalau misalnya kita lagi mau mau bikin promosi, misalnya promosi, atau kita nggak usah promosi deh, kita tahu tiap hari Jumat pasti orang yang buka Tokopedia lebih banyak. Nah, orang Tokopedia bisa nyiapin servernya lebih gede di situ karena ada forecasting based on time series. Tuh, kita juga bisa ngelakuin dengan time series ini, kita juga bisa memahami apa sih yang terjadi, kenapa sih itu bisa terjadi berdasarkan variabel waktu ya. Dan kita juga bisa melakukan apakah kita sedang downtrend, performa kita, performa perusahaan kita, performa organisasi kita. Itu gunanya time series. Terus kenapa sih ada time series? Kita dari awal intro to machine learning, terus kita juga ngomongin deep learning, ngomongin banyak hal tentang machine learning. Time series ini mungkin masuknya ke supervised machine learning ya. Jadi, tapi kenapa ada time series dan di terakhir lagi ya? jadi kalau teman-teman mungkin sebelumnya udah mempelajari beberapa model machine learning atau teori machine learning. Kalau di machine learning kita mungkin pernah belajar ketika misalnya kita mau memprediksi penjualan es krim ya atau penjualan susu ya, karena kalau biasanya berdasarkan suhu orang yang beli es krim lebih banyak misalnya. Let's say kita ada di Bandung atau di Surabaya ya, range suhunya itu dari 18 derajat sampai di Surabaya kira-kira paling panas berapa? Mungkin 30 nyampe nggak ya? Mudah-mudahan 30 nyampe ya, tapi mudah-mudahan nggak sampai kayak di UK yang lagi sedang badai panas gitu ya. Jadi itu kita bisa forecast, kalau suhunya ada di range sekian, nanti penjualannya akan ada di sekian. Tapi itu kan bisa ditebak karena dia ada di range. Jadi suhu, kecuali kejadian kayak event badai panas gitu yang suhunya sampai 40 derajat amit-amit gitu ya, mudah-mudahan nggak kejadian di Indonesia. Itu baru kita menebak sesuatu yang kita datanya nggak punya. Tapi kalau di interpolate, kayak misalnya kita nebak dengan cara suhu tadi, kita pasti punya datanya. Most likely besok itu nggak akan jauh-jauh range-nya. Dan kalau range-nya akan jatuh di misalnya 25 derajat, berarti forecast kita juga nggak akan jauh-jauh dari data yang kita punya. Tapi kalau di time series, di sini kita akan nebak atau memprediksi sesuatu yang datanya kita nggak punya, gitu. Jadi kita menebak besok, yang data kita punya adalah hari ini atau kemarin, gitu ya. Jadi itu kita sebut ekstrapolasi. Tuh, jadi kenapa time series penting untuk memudahkan kita melakukan prediksi-prediksi yang di luar data yang kita punya. Gitu. Nah, seperti saya bilang tadi, time series itu banyak digunakan untuk forecasting ya. Jadi kalau kita ngomongin tadi judulnya juga forecasting, di forecasting itu ada yang kita kenal sebagai forecasting tourism. Jadi yang pertama di tourism ini seberusaha kita mungkin untuk melakukan prediksi atau forecasting itu selalu salah gitu ya. Makanya nggak usah overfitting gitu ya. Jadi jangan sampai di overfit datanya dan bisa memprediksi mungkin data trainingnya akurasinya besar, tapi pas dites atau pas bahkan untuk di real production deployment itu akurasinya bisa jauh lebih rendah. Jadi pasti forecast itu salah. Makanya nggak usah sampai overfitting. Kalau ada kesempatan untuk menggunakan model yang lebih simple, model yang lebih gampang gitu ya, itu pakai yang model yang lebih simpel dibanding kita bikin model yang complicated dan akhirnya overfit dan jadinya salah juga. Terus tourism yang kedua adalah kita itu ketika kita memforecast sesuatu itu jadi biasanya kalau diagregasi itu biasanya lebih akurat. Contoh ini ada grafik yang di sebelah kanan, grafik yang di sebelah kanan ini contohnya ini adalah satu case ya, satu case misalnya di Starbucks. Di Starbucks itu kita pakai kalau kita ke Starbucks kita bisa lihat ada 3 jenis cup di situ, cup yang kecil, cup sedang, cup yang gede gitu. Anggaplah kita adalah produsen cup ya gitu, atau produsen tutupnya cup gitu ya. Kalau tutupnya cup itu masing-masing beda ngikutin size cupnya, berarti orang yang di produsen cupnya ini akan makin susah memforecast berapa sih yang harus saya produksi di minggu ini atau di hari ini gitu. Nah, itu akan susah banget. Tapi kalau kita misalnya kita gabungin, kalau kita lihat di Starbucks itu akhirnya walaupun size cupnya beda-beda, size tutupnya sama, gitu ya, size tutupnya sama. Dan ketika disamain, orang yang jadi produsen tutupnya cup ini, dia akan lebih mudah memforecast, gitu ya. Kalau dilihat di gambar yang bawah, mungkin saya kasih ini kali ya. Di gambar yang bawah sini, ini adalah agregasi dari 3 produksi ini. Jadi kalau kita memproduksi, kita samain size cupnya, size tutupnya, walaupun size cupnya beda-beda, maka produsen tutupnya itu akan lebih gampang memforecast. Jadi aggregated forecast itu cenderung lebih akurat. Atau contoh lain misalnya yang diagregasi. Kalau weekly biasanya kayak gini nih CV-nya gede banget gitu ya, koefisien variasinya atau standar deviasi per mean gitu ya, itu biasanya lebih gede. Tapi ketika kita agregasi jadi demand bulanan, itu biasanya lebih stationary, lebih gampang atau lebih akurat untuk diprediksi gitu ya. Itu tourism yang kedua. Tourism yang ketiga adalah ketika kita memforecast hampir semua model, ketika kita memforecast jangka waktu yang lebih panjang atau horizon yang lebih panjang, itu biasanya akurasinya akan lebih rendah gitu, karena bisa jadi biasanya lebih tinggi atau akurasinya jauh gitu ya. Gitu. Jadi contohnya di sini ketika kita memprediksi jauh dari data yang kita punya, maka profesinya lebih rendah dan dia juga biasanya lebih jauh juga. Gitu. Oke, nah ini kalau teman-teman udah buka Kaggle-nya, challenge di Kaggle, di situ ada beberapa materi ya. Yang pertama adalah regresi biasa atau kita sebutnya stationary atau level gitu ya. Rumusnya sih gampang ya. XT itu adalah sesuatu yang mau kita data yang kita observasi biasanya berdasarkan rumus linear tertentu gitu ya. Jadi kita sebutnya level atau stationary. Terus ada juga yang kita sebut dengan tren. Nah, tren ini biasanya ada tren naik atau tren turun. Biasanya kita bisa lihat dari misalnya penjualan atau pendapatan kita dari tahun ke tahun atau dari bulan ke bulan kok ada naik nih, kayaknya 10 bisa naik secara statis. Nah, biasanya bisa kita lihat trennya seperti ini. Gitu. Atau seasonal gitu ya. Seasonal itu berarti dia ada naik turunnya, tapi ada polanya, ada patternnya gitu ya, ada patternnya. Dan ada cyclical juga. Nah, bedanya apa seasonal sama cyclical? Jadi kalau seasonal itu biasanya kita lihat patternnya berdasarkan time series yang ada gitu ya. Kalau cyclical biasanya ternyata nggak dependent si variabel ini nggak dependen sepenuhnya sama waktu, tapi dia ada variabel-variabel yang lain yang bisa jadi features juga di situ. Kalau seasonal biasanya fully waktu, misalnya kalau kita misalnya kita punya toko buku gitu ya, toko buku pasti penjualannya naik ketika masa-masa anak mau masuk sekolah, atau misalnya bulan Juli, bulan Mei sampai Juli, atau bulan Desember sampai Januari misalnya itu. Nah itu seasonal. Tapi ada juga yang cyclical. Nah cyclical ini cenderung lebih nggak bisa ditebak. Jadi contohnya kayak ekonomi downturn gitu ya. Misalnya ada yang bilang krisis tuh tiap 8 tahun sekali, tapi sebenarnya nggak valid juga. Kadang-kadang terjadi 10 tahun sekali, kadang-kadang 12 tahun sekali, kadang-kadang 15 tahun sekali. Nah itu cyclical. Nggak ada pattern yang benar-benar berdasarkan waktu gitu ya. Jadi kalau seasonal biasanya misalnya dia naik di bulan Desember, nanti dia naiknya akan di bulan Desember lagi. Jadi patternnya mirip gitu ya. Kalau cyclical patternnya nggak berdasarkan waktu, tapi mungkin faktor-faktor lain. Dan terakhir ada randomnya ya, jadi ada faktor-faktor error gitu ya. Nah ini seasonal nih misalnya yang cyclical yang seperti ini nih. Jadi di sini tutup. Kalau di sini misalnya price of oranges. Nah di sini sebenarnya kayak seasonal, tapi sebenarnya seasonalnya nggak bisa ditebak. Itu kapan sih naiknya, bulan apa? Itu nggak ada. Atau US unemployment kayak seasonal, tapi sekali lagi itu nggak ada pattern yang jelasnya. Kapan dia naik, kapan dia turun, bulan apa, atau jam berapanya gitu ya. Masing-masing dari model ini itu masih bisa dibentuk dalam multiplikatif atau aditif. Jadi misalnya ini digabung ya. Berarti di grafik yang satu ini dia ada trennya juga. Kalau kita lihat di sini naik, ada seasonalnya juga, tapi mungkin ada cyclicalnya juga. Nah itu detailnya bisa dipelajari di Kaggle ya. Nah kalau kita mau forecast, biasanya ada beberapa model yang simple ya gitu ya. Kita ngomongin basicnya dulu, yang simple-simple dulu. Jadi yang pertama adalah kumulatif gitu ya. Kumulatif itu semua data yang kita punya itu matters atau bernilai gitu ya. Kalau ada lawannya adalah naif. Jadi satu ekstrim yang pertama, kalau kita punya data 1000, maka semua 1000 data itu penting, bernilai untuk forecast selanjutnya. Atau naif, yang kalau kita punya data 1000, data terakhir doang yang penting, data 999-nya nggak penting, gitu ya. Jadi kalau kita lihat di grafik ini, kumulatif itu kalau kita punya data 10, berarti kumulatif nih forecastingnya jadi akan kayak gini nih. Tapi kalau naif, kita memforecast hari besoknya pasti akan sama dengan hari kemarin. Kalau aktualnya berarti yang biru ya, kita akan memforecast berarti besok akan sama dengan hari kemarin. Itu naif, gitu ya. Tapi kan nggak bisa ya, kita langsung pakai aja modelnya kayak gitu. Jadi ada somewhere in between kumulatif sama naif gitu ya. Ada yang kita sebut moving average. Nanti akan dijelasin di belakang juga moving average itu kayak gimana. Atau ini grafiknya kayak gini ya. Jadi dari waktu ke waktu rata-ratanya tuh naik gitu ya. Ini data aslinya, terus moving average yang biru. Gitu. Tapi biasanya kalau moving average tetap aja kita gunain data ini secara bobotnya sama gitu ya, hampir mirip sama kumulatif. Terus ada juga yang kita sebut dengan hold winter. Nah, hold winter ini lebih ke dari data yang ada, kita kasih bobot. Jadi data yang paling recent, paling terbaru itu bobotnya lebih besar dibanding data yang sebelumnya. Jadi ada koefisien, kita bisa sebut alfa atau beta gitu ya, yang makin lama dia akan menurunkan makin ke belakang datanya itu bobotnya makin rendah gitu ya, jadi 1 minus alfa gitu. Jadi tapi paling recent, paling baru datanya itu bobotnya paling tinggi. Jadi nggak semua yang kita punya di data itu bernilai, tapi ada nilainya, tapi makin recent itu makin tinggi bobotnya gitu. Atau ada juga yang disebut DAM. Karena kita tahu ya, misalnya kita ngomongin forecast, oh kita kayaknya naik nih, ada trennya. Tapi kita tahu sebenarnya tren itu nggak selalu ada gitu ya, pasti ada turunnya. Jadi kalau kita pakai modeling biasa linearnya, dia akan ini aktualnya ya, yang ada di sini aktualnya lama-lama tuh makin off gitu ya, makin bias gitu ya forecast kita. Jadi kita kasih faktor DAM, yang nanti dia tren itu makin normalize, makin turun gitu ya. Itu faktor DAM-nya. gitu ya. Matematika modelnya mungkin nggak di Kaggle ya. Saya juga lupa masukin rumusnya di sini. Tapi mudah-mudahan basic konsepnya kebayang. Gitu. Nah, mungkin sesi ini dilanjut sama Mas B ya.
Oke, terima kasih Mas Ray. Mungkin kita langsung untuk yang selanjutnya kita langsung masuk ke ini aja Mas, Arima, Arima. Untuk stationer ini, ya oke. Untuk langsungnya kita basic konsepnya kita langsung di machine learning model. Kita menggunakan nantinya yang akan digunakan di sini adalah dari mulai Arima dan Sarima, kemudian ada Prophet atau Neural Prophet sama Exibus gitu. Next, Mas Ri. Oke. Sedikit penjelasan tentang Arima dari Auto-Regressive Integrate Moving Average gitu ya, kalau kita singkat. Jadi si Arima ini sering juga disebut metode runtun waktu Box-Jenkins, di mana sangat baik ketepatannya untuk peramalan jangka pendek. Sedangkan untuk peramalan jangka panjang, ketepatan peramalannya kurang baik. Jadi kalau misalkan di Arima ini, atau misalkan kita melakukan di Auto-Regressive Integrate Moving Average ini, biasanya yang akan kita lakukan untuk peramalan-peramalan dengan jangka waktu yang tidak panjang gitu ya. Bisa jadi kayak misalkan per bulan atau per tahun atau maksimum di 2-5 tahun gitu. Model dari Arima sendiri, dia secara penuh mengabaikan independent variable dalam membuat peramalan, sehingga menggunakan nilai masa lalu dan sekarang dari variable independent untuk menghasilkan peramalan jangka pendek yang akurat nantinya. Jadi kalau Arima sendiri cocok untuk observasi dari deret waktu atau time series yang secara statistik berhubungan satu dengan yang lainnya atau dependent. Nah, untuk yang kita lakukan di sini sebagai contoh dari time series machine learning modelnya, kita akan menggunakan salah satunya adalah model auto-regressive, di mana model regresi time series yang menghubungkan nilai pengamatan aktual dan nilai pengamatan sebelumnya, itu akan kita gabungkan sehingga dapat dilakukan ketika pengamatan tidak lepas dari data yang terjadi sebelumnya. Jadi konsep dasar dari ini yaitu meregresikan pengamatan aktual dengan nilai pengamatan sebelumnya untuk melakukan peramalan nilai ke depan. Yang kita gambar sebagai contoh di bawah itu adalah chart emas untuk 10 tahun terakhir, di mana dari pengamatan-pengamatan untuk yang biasanya nilai yang contohnya, salah satu contohnya kenapa emas, karena salah satu yang nilainya selalu naik gitu ya, atau istilahnya yang stabil itu biasanya kita dilihat dari nilai emas gitu. Namun kalau misalkan kita mau buat satu time series model, kita bisa nggak hanya menentukan 1 tahun. Kalau dari sisi emas sendiri, kita biasanya minimal 10 tahun untuk kita bisa amati gitu. Ini contoh dari datanya. Jadi kalau misalkan kita menggunakan model autoregresif, kita biasanya butuh data-data sebelumnya, misalkan 5 atau 10 tahun, sehingga ketika kita buat satu analisanya dari misalkan bagian dari SA5-nya, autoregresif ini memang membutuhkan waktu yang cukup lama nantinya. Nah, di sebelahnya mungkin yang sudah dibahas tadi metode moving average, biasanya menggunakan rata-rata beberapa data terakhir sebagai data perakiraan masa berikutnya. Nah, metode ini sangat sederhana karena berusaha merata-ratakan beberapa data terakhir. Metode ini meluruskan perubahan data yang sangat tinggi atau sangat rendah. Moving average digunakan untuk menganalisa data point dengan membuat rata-rata beberapa subset yang berbeda. Nah, di moving average sendiri, ini digunakan biasanya dalam perhitungan dunia finansial, khususnya data saham, di mana sering digunakan oleh investor untuk indikator saat melakukan analisa teknikal. Biasanya investor ataupun trader, mereka tuh biasanya mempertimbangkan ya salah satu faktornya, contohnya salah satu dari saham, mengetahui harga rata-ratanya gitu. Misalkan dari average dari rata-rata dari harga yang terakhir itu seperti apa gitu. Nah, dengan melihat moving average, kita bisa melihat arah tren saham, terus kemudian kurva moving average akan bergerak ke atas jika harganya naik, sesuai dengan gambar contoh di bawah, atau misalkan ke bawah atau jika harganya turun, atau biasanya kita sebut sebagai uptrend, ke bawah biasanya disebut downtrend ya di bawah itu. Ada dua hal terkait moving average ini. Itu biasanya digunakan simple moving average, adalah bentuk yang paling sederhana dari moving average, atau yang selanjutnya itu exponential moving average, atau moving average indikator yang lebih responsif terhadap informasi atau perubahan yang baru. Gitu. Next, Mas Rey. Oke, model selanjutnya adalah itu kita menyebutkan dari Sarima. Kalau Sarima itu adalah salah satu model yang merepresentasikan data time series yang memiliki perilaku musiman atau seasonal. Arima atau seasonal dari Arima. Dengan model ini diharapkan nantinya data time series yang memiliki perilaku musiman itu akan bisa direpresentasikan untuk bisa dibuat forecast-nya. Salah satu contoh yang ada di bawah ini adalah dari contoh modeling secara Arima dengan data dari tebu ya, ini dari contoh dari data panen tebu, di mana data panen tebu ini nggak setiap saat, jadi dia musiman, dan kita ambil berdasarkan prediksi dari musim-musim dari panennya gitu. Jadi contohnya misalkan kita bisa menggunakan si S-nya itu, kalau misalkan di Arima bisa 12 bulan, kalau misalkan si biasanya Arima itu kita bisa menggunakan dari 12 bulan, kalau misalkan S Arima itu kita bisa ngambil sebagai contoh dari per 6 bulan musim panennya, atau misalkan kita beli persingkat menjadi 3 bulanan gitu ya. Dan ini juga sangat tepat kalau misalkan kita menggunakan S Arima itu sebagai prediksi-prediksi dari harga-harga bahan pokok gitu. Kalau misalkan berdasarkan dari harga bahan pokok yang berdasarkan dari waktu panennya gitu. Kalau misalkan kita mau buat modeling, salah satu contohnya. Next, di sebelah kanan itu ada satu model juga, namanya kita sebut sebagai prophet model, yang didasarkan dari algoritma untuk melakukan prediksi dari data yang berbentuk time series, yang berdasar dari model adiktif, yang dimana tren yang bersifat non-linear akan dicocokkan dalam deret waktu secara tahunan. Nah, mingguan dan harian, dengan efek libur atau Taylor, ini dari Taylor dan Latham tahun 2018. Algoritma ini berfungsi dengan sangat baik dengan data time series yang memiliki efek musiman yang kuat dan dataset yang punya banyak data. Prophet bersifat robust terhadap data yang hilang dan bergerak dan pergerakan tren, dan juga dapat menangani outliers dengan baik. Secara dasar, Prophet merupakan additive regression model dengan 4 komponen utama. Itu yang pertama itu biasanya ada kurva pertumbuhan linear atau logistik, yang dimana Prophet dapat secara otomatis mendeteksi perubahan tren dengan memiliki titik perubahan dari data. Itu dapat lihat di bawah sebagai contohnya. Kemudian komponen yang kedua biasanya komponen tren tahunan yang dimodelkan menggunakan Fourier series ya, dan komponen tren mingguan menggunakan variable dummy serta daftar hari libur penting yang disediakan oleh user. Nah, biasanya model Prophet ini digunakan sebagai contoh, ini di bawah ini adalah penggunaan dari data dari data Bandung.GITS.ID, di mana ada beberapa data yang ini juga diambil dari data pangan, ada beberapa data yang memang itu tidak ada di tahun 2010, itu tidak lengkap gitu. Makanya bisa dimasukkan ke dalam metode Prophet model, di mana data-data yang tidak lengkap nantinya itu bisa digabungkan, otomatis mendeteksi perubahan dari trennya. Itu kan kita bisa lihat dari dot-dotnya itu, di mana ketika misalkan dia tidak ada terlengkapi, otomatis nantinya mendeteksi perubahan dari trennya. Itu bisa menggunakan metode dari Prophet model. Next, mohon maaf Mas Rey. Oke, yang terakhir yang akan kita menggunakan adalah dari metode XGBoost itu sendiri, XGBoost ya. XGBoost adalah implementasi dari algoritma ensemble penambah gradient untuk klasifikasi dan regresi. Kumpulan data deret waktu dapat diubah menjadi pembelajaran yang diawasi menggunakan sliding window representasi. Dalam mesin learning biasanya peningkatan gradien, algoritma yang membantu melakukan tugas regresi dan klasifikasi itu di XGBoost, kemudian dia akan menggunakan unensemble model prediksi yang lemah, dan kemudian akan mendapatkan peningkatan gradien, dan kemudian nantinya membantu dalam sisi modelingnya itu sendiri. Nah, biasanya ini sebagai di bawah ini kan kita menggunakan, kalau XGBoost ini menggunakan decision tree, di mana secara arsitekturnya nantinya model yang lemah dan misalkan sebagai contoh model yang lemah dalam decision tree, model example yang menggunakan quick trace learner dapat dianggap sebagai pohon yang nantinya dia didorong oleh gradien. Sebagai informasi lanjutan, nanti pohon yang didorong gradien sebanding dengan kayak misalkan decision tree hutan acak, yang meskipun mereka dapat bekerja dengan lebih baik daripada yang lain, jika di setel dengan baik, itu akan membantu dalam mengeneralisasi model lain dengan mengoptimalkan fungsi dari diferensiasi dari waktu yang ada gitu nantinya gitu. Sebagai gambaran dari XBoot itu nanti. Nah, untuk selanjutnya kita akan langsung kepada metode praktek yang akan dipandu oleh Mas Arya sama Mbak Jihan. Jadi untuk pengenalan model-model yang di atas itu akan langsung kita implementasi dalam sisi praktek selanjutnya. Mungkin saya persilahkan kepada Mbak Jihan yang terlebih dahulu ya, Mbak. Silakan Mas Arya.
Izin share screen dulu ya. Oke, perkenalkan nama saya Jihan. Di sini saya akan mendemokan salah satu programnya dari time series. Mungkin dari teman-teman bisa upload dulu filenya ke Colab ya, seperti ini. Nah, jadi data yang kami pakai itulah data dari TCS Stock tahun 2015, jadi merupakan data saham, kayak gitu. Nah, untuk membuat time series ini ada beberapa library yang kita butuhkan. Yang pertama ini ada library warnings, terus ada library pandas, ada matplotlib, seaborn, terus skitlearn, dan juga stats models ya. Nah, lalu untuk di sini ini ada algoritma untuk set matplotlib. Jadi untuk set style grafiknya kita menggunakan algoritma ini. Lalu di sini untuk import datasetnya ya, yang sudah kita masukkan ke kolom ini, kita import datasetnya menjadi data frame. Nah, ini data frame-nya yang akan kita gunakan untuk time series-nya ini sendiri gitu. Nah, untuk membuat time series ini butuh untuk membuat linear trend modelnya. Jadi di sini ada beberapa fungsi yang dibutuhkan untuk membuat linear trend model. Yang pertama ini ada fungsi moving average ya. Jadi moving average ini untuk melihat tren seperti apa pada data tersebut gitu singkatnya. Di moving average ini ada data rolling. Jadi rolling ini salah satu metode dalam moving average juga untuk membentuk window computation-nya seperti itu. Kemudian di sini window-nya ini sendiri itu kita masukkan 365. Jadi kenapa 365? Jadi dari data ini itu berdasarkan perharinya gitu. Jadi ada 1 Januari, 2 Januari, dan seterusnya. Nah, dari data per hari ini bisa dikatakan sebagai daily observation gitu. Sehingga window-nya ini kita ukur dalam setahun itu ada 365 hari, jadi kita masukkan 365-nya. Lalu mean period-nya ini itu 183 ya, berarti setengah ukuran size window-nya gitu. Bisa dibilang perhitungan hari dengan menggunakan moving average-nya gitu. Ini sebenarnya bebas, tapi di sini kita memasukkannya 183. Kemudian di fungsi selanjutnya itu ada linear regression. Nah, yang mana linear regression-nya ini untuk melihat dalam grafik data tersebut itu memiliki nilai yang tepat naik atau tepat turun ya. Jadi untuk beberapa grafik itu terlebih line chart, dia akan naik turun, dan terkadang juga sulit untuk melihat apakah data tersebut sudah pasti naik atau turun. Jadi perlunya linear regression ini atau menarik garis untuk melihat bahwa grafik tersebut itu bisa tepat naik atau tepat turun gitu. Lalu untuk yang fungsi selanjutnya ini, forecast and plot using linear regression. Jadi di sini untuk melihat perkiraan dari data tersebut, di sini target value-nya sama dengan 30 hari ke depan. Jadi melihat dalam 30 hari ke depan itu datanya akan seperti apa. Nah, di out of sample ini salah satu pintu untuk menghitung di luar periode waktu dalam data, di mana steps-nya sama dengan 30, sesuai dengan target value-nya sama dengan 30 hari ke depan gitu. Lalu untuk di sini fungsi matplots untuk mengcombine beberapa fungsi sebelumnya menjadi satu data visualisasi. bisa dibilang jadi satu grafik yang sama kayak gitu. Setelah dari 3 fungsi ini, lanjut di sini ada deterministic process. Ini salah satu fungsi untuk membuat fitur data untuk forecast-nya nanti. Jadi di dalam datanya ada hari-hari dari bulan Januari sampai di Desember akhir ya, di tahun 2015. Jadi ini untuk membuat fitur datanya untuk melihat hari-hari setelah setahun tersebut di forecast-nya gitu. Nah, ini berikutnya adalah bentuk dari visualisasi datanya ya. Jadi di sini kita mengambil high price sama low price. Jadi dalam beberapa kolom data di sini kita mengambil high sama low-nya. Nah, untuk yang pertama ini high price linear trend dari data set TCA stock, di mana yang birunya ini itu merupakan garis moving average-nya. Nah, kemudian untuk yang merahnya ini, itu merupakan garis trendline-nya atau bisa dibilang linear regression-nya, seperti itu. Dan di grafik ini, trendline-nya terlihat menurun gitu ya. Kemudian yang hijaunya ini, itu adalah grafik forecast line-nya gitu, atau garis perkiraannya setelah setahun itu, ya 30 hari ke depannya itu seperti apa. Ternyata garis forecast line-nya ini mengikuti garis trendline-nya, yaitu sama-sama garisnya ikut menurun gitu. Sama juga untuk grafik yang low price, yang biru ini juga sama moving average, kemudian yang merah ini juga sama, dia trendline-nya sama-sama juga seperti high price, di mana yang di low price itu juga menurun, kemudian untuk yang di forecast line ini juga mengikuti trendline-nya ya, jadi dia ikut menurun, seperti itu. Nah, mungkin itu dari saya untuk penjelasan dari trend time series. Mungkin selanjutnya bisa teman saya untuk menjelaskan model-model yang lainnya.
Oke, baik Jihan. Jadi saya akan melanjutkan untuk metode selanjutnya yang akan kita gunakan untuk menganalisis time series. Jadi, perkenalkan kembali, nama saya Arya Bagus. Jadi, metode selanjutnya yang akan kita gunakan itu adalah metode seasonality-nya. Jadi saya di sini akan menjelaskan salah satu program yang dapat kita gunakan untuk menganalisis time series dengan metode seasonality. Oke, jadi di program kita, pertama-tama kita perlu mengupdate terlebih dahulu beberapa packages yang akan kita gunakan dalam program kali ini. Selanjutnya, kita akan mengimport terlebih dahulu packages yang akan digunakan. Di antaranya ada Pandas, kemudian ada Matplotlib dan juga Seaborn untuk memvisualisasi plot, dan ada sklearn, stats model, dan SciPy yang akan kita gunakan untuk melatih machine learning model kita untuk nanti membentuk prediksi dan juga forecast. Nah, kemudian rangkaian kode ini kita gunakan untuk mengeset default style dari visualisasi yang akan ditampilkan oleh Matplotlib nantinya. Kemudian kita akan mengimport data, yaitu berupa data sum TCS pada tahun 2015. Kemudian kita mengeset data frame kita supaya memiliki indeks yang berupa date yang sudah dibentuk datanya menjadi 2 period, jadi berdasarkan periode harinya begitu. Dan ini adalah data frame yang akan kita gunakan dalam program kita kali ini. Oke, jadi pertama untuk melakukan analisis time series dengan metode seasonality ini, kita akan membuat beberapa fungsi untuk melakukan programnya. Jadi fungsi yang pertama akan kita buat adalah fungsi seasonal plot, di mana fungsi ini tuh tujuannya adalah untuk membuat sekaligus memvisualisasikan seasonal plot bergantung terhadap periode dan frekuensi yang kita pilih. Oke, jadi apa yang dimaksud dengan periode dan frekuensi? Jadi saya akan langsung melihat hasil visualisasi seasonal plotnya. Jadi di sini ada 2 bentuk visualisasi. Yang di sebelah kiri adalah seasonal plot dengan periode week dengan frekuensi day, dan yang sebelah kanan adalah seasonal plot dengan periode year dengan frekuensi day of year. Adalah berarti kita membagi data kita menjadi per minggunya, dan kita akan memplot data-data per harinya pada minggu tersebut gitu. Kemudian jika kita memilih seasonal plot dengan periode year dengan frekuensi day of year, itu artinya kita membagi data kita menjadi setiap tahun, membagi data kita menjadi per tahunnya, dan kita akan memvisualisasikan data per harinya pada tahun tersebut. Jadi itu ada yang dimaksud dengan periode dan frekuensi, dan itu adalah fungsi dari seasonal plot yang akan kita definisikan ini. Selanjutnya, kita akan mendefinisikan sebuah fungsi baru juga, yaitu namanya plot periodogram, di mana tujuan dari fungsi ini adalah untuk membuat sekaligus memvisualisasikan periodogram yang akan kita gunakan untuk memilih berapa banyak jumlah persamaan Fourier yang optimal untuk melatih machine learning model kita. Jadi kita akan langsung menggunakan fungsi yang pertama kita buat, itu fungsi seasonal plot. Jadi karena di sini kita akan menggunakan periode week dengan frekuensi day dan juga periode year dengan frekuensi day of year, maka ada beberapa hal yang perlu kita tambahkan ke dalam data frame kita. Yang pertama adalah karena kita menggunakan periode week dengan frekuensi day, maka kita perlu menambahkan sebuah column week di mana akan memuat data berupa pada week keberapakah data kita pada tanggal tersebut. Dan kita juga akan menambahkan sebuah column day yang akan memuat pada data kita pada tanggal tersebut, pada week tersebut juga, termasuk pada hari keberapa gitu. Jadi hari apa. Jadi di sini contohnya pada tanggal 1 Januari 2015, data ini itu adalah pada minggu pertama pada tahun 2015, dan 1 Januari itu adalah day keempat. Nah di sini 3 karena indexing dari Python itu dimulai dari 0, jadi 3 tambah 1 which is 4, jadi itu adalah hari Kamis gitu. Selanjutnya, jika kita memilih periode year dengan frekuensi day of year, maka kita akan perlu menambahkan kolom year, di mana akan memuat data berupa pada tahun berapakah data kita pada saat itu, dan menambahkan kolom day of year, di mana akan memuat pada data kita itu, data kita pada tahun tersebut itu termasuk ke hari keberapa gitu. Jadi di sini pada tanggal 1 Januari itu termasuk pada hari pertama pada tahun 2015 begitu. Jadi setelah kita menambahkan kolom-kolom tersebut, kita dapat menggunakan fungsi seasonal plot untuk membuat seasonal plotnya. Jadi pertama di sini rangkaian kode yang di atas itu adalah digunakan untuk membuat seasonal plot, baik dari menggunakan periode week dengan frekuensi day dan juga dari periode year dengan frekuensi day of year untuk high stock price saham TCS. Sementara yang di bawah adalah untuk yang low stock price-nya. Dan ini adalah visualisasi yang dihasilkan dari fungsi kita. Oke, jadi pertama kita akan melihat terlebih dahulu visualisasi yang ada di sebelah kiri atau seasonal plot untuk periode week dengan frekuensi day. Oke, jadi bagaimana cara kita dapat mendapatkan informasi untuk melatih machine learning model kita adalah kita melihat terlebih dahulu apakah terdapat sebuah pola khusus yang dapat kita amati dari visualisasi yang sudah dihasilkan. Nah, di sini kita lihat bahwa tidak terdapat sebuah pola khusus ya, ini agak berantakan bentuknya. Nah, maka dari itu kita belum bisa menggunakan seasonal plot dengan periode week dengan frekuensi day untuk melatih machine learning model kita. Maka dari itu, kita akan beralih ke seasonal plot yang kedua, yaitu seasonal plot dengan periode year dan frekuensi day of year. Nah, untuk melatih machine learning model kita, menggunakan periode dengan frekuensi ini, kita perlu menentukan berapa jumlah persamaan Fourier yang optimal untuk melatih machine learning model kita. Maka dari itu, kita akan menggunakan fungsi sudah kita buat, itu fungsi plot periodogram. Nah, ini adalah bentuk periodogram, ini adalah bentuk dari visualisasi periodogram, baik untuk high stock price maupun dari low stock price-nya. Oke, jadi bagaimana cara kita membaca visualisasinya? Ini adalah sebagai berikut. Jadi kita perhatikan di sumbu Y itu adalah nilai variance-nya. Jadi kita harus menentukan kapan nilai variance ini mengalami penurunan yang cukup drastis, di mana penurunan ini mencapai nilai 0 gitu. Nah, mendekati nilai 0, sorry. Jadi di sini dapat kita lihat penurunan yang cukup drastis itu ada di sini, dan penurunan juga sudah cukup mendekati 0, di mana jatuh di antara monthly dan biweekly, di mana di sini adalah antara 12 persamaan Fourier dan 26 persamaan Fourier. Nah, karena lebih dekat ke arah 26 persamaan Fourier, maka kita akan mencoba untuk memilih sebanyak 22 persamaan Fourier untuk melatih machine learning model kita. Nah, dengan prosedur yang sama, kita akan menentukan nilai optimal untuk persamaan Fourier untuk low stock price. Di sini ternyata sama juga, jatuh itu di sekitar sini, dan maka dari itu kita akan memilih sebanyak 22 persamaan Fourier juga untuk low stock price. Oke, selanjutnya di sini kita akan membuat sebuah fungsi, yaitu create and plot models, di mana tujuannya adalah untuk membuat sekaligus memvisualisasikan seasonal plot, yang nantinya seasonal plot ini akan memuat data yang kita miliki, prediksi data hasil machine learning model kita, dan juga forecasted data sebanyak 7 days forecasted data dari machine learning model kita. Oke, jadi sedikit penjelasan terkait fungsi. Pertama, kita akan menginisiasi sebuah parameter Fourier yang akan memuat persamaan Fourier yang nanti akan melatih machine learning model kita. Selanjutnya kita akan membuat sebuah parameter DP yang akan dijalankan menggunakan fungsi deterministic process yang tujuannya untuk membuat features data untuk forecast data kita nantinya. Selanjutnya, kita akan melatih machine learning model kita dengan algoritma yaitu linear regression. Kemudian kita akan membentuk prediksi dari machine learning model yang sudah kita latih. Nah, kemudian kita akan membentuk features data menggunakan features data untuk forecast data kita nantinya. Dan kita akan menggunakan machine learning model kita untuk untuk menentukan forecast menggunakan features forecast data kita. Nah, terus rangkaian kode ini itu akan kita gunakan untuk menghitung RMSE yang bertujuan untuk mengetahui bagaimana performa machine learning kita dalam membentuk prediksi gitu. Terakhir, kita akan memvisualisasikan perhitungan prediksi yang sudah kita lakukan ke dalam satu visualisasi yang sama. Oke, jadi di sini kita akan menjalankan fungsinya kita, dan berikut ini adalah hasil prediksi, hasil visualisasi yang dihasilkan. Oke, jadi di sini ada dua visualisasi, di mana yang atas adalah visualisasi untuk seasonal plot high stock price, sementara yang di bawah adalah low stock price. Di sini dapat kita lihat garis biru itu adalah actual data yang kita miliki, sementara garis oranye itu adalah data hasil prediksi machine learning kita, dan yang hijau adalah model forecast yang dihasilkan dari machine learning kita, di mana kita akan memforecast sebanyak 7 hari ke depan. Nah, di sini dapat kita lihat bahwa model prediction yang kita hasilkan itu dapat cukup menyamai actual data yang kita miliki. Dan juga di sini kita lihat bahwa RMS itu cukup rendah, itu di kisaran 23. Nah, untuk mengetahui apakah 23 ini rendah atau tinggi, kita dapat menilainya sebagai berikut. Jika di sini kita lihat data adalah 2.600 gitu. Jadi karena RMS kita tuh kisarannya 23, maka prediksi kita tuh mungkin kemungkinan salahnya itu di antara 26 plus 23 atau 26.000 dikurangin 23 gitu. Nah, karena cuma selisih 23 angka, maka dari itu kita dapat menilai bahwa prediksinya cukup dapat menyamai gitu. Nah, maka dari itu kita dapat memiliki cukup keyakinan bahwa forecast yang dihasilkan itu bisa lumayan akurat dalam memprediksi harga beberapa hari ke depan. Dalam kondisi ini kita memprediksi 7 hari ke depan. Jadi itu adalah program yang dapat kita gunakan untuk menganalisis time series menggunakan metode seasonality-nya. Selanjutnya, kita juga ada metode terakhir yang metode selanjutnya yang dapat kita gunakan itu dengan menganalisis serial dependence-nya. Nah, jadi selanjutnya saya juga akan menjelaskan terkait program yang akan dapat kita gunakan untuk menganalisis time series dengan metode serial dependence-nya. Oke, jadi alurnya sama, kita akan mengupdate terlebih dahulu packages yang akan kita gunakan. Selanjutnya, kita akan mengimport terlebih dahulu packages yang akan kita gunakan. Sama juga seperti sebelumnya, kita akan mengeset kembali default style dari visualisasi yang akan ditampilkan oleh Matplotlib, dan kita akan mengimport data saham TCS ke dalam environment Google Colab kita. Nah, di sini kita pada analisis time series menggunakan serial dependence, kita akan mengeset data frame kita untuk memiliki indeks yang berupa date yang sudah diset berdasarkan frekuensi per harinya begitu. Dan ini adalah data frame yang akan kita gunakan. Oke, jadi pada analisis time series menggunakan serial dependence, kita tentunya harus membentuk features data dan targets data. Nah, jadi pada serial dependence ini, features data akan memuat sebanyak n leg data dari data asli yang kita miliki, dan targets data akan memuat sebanyak n steps data dari data yang kita miliki. Oke, sekarang apa sih yang dimaksud dengan n legs dan n steps data? Jadi gini, misalkan kita ini pada tanggal 5 Januari 2015. Jadi yang dimaksud dengan one leg data itu adalah data satu row sebelum ini gitu, which is tanggal 2 Januari ini. Nah, kalau misalnya kita memilih 2 leg data, maka ada 2 row sebelumnya gitu, itu 1 Januari 2015 gitu. Nah, untuk n steps itu konsepnya sama, cuman dia row-nya ke depan gitu. Berarti di sini kalau misalnya one steps from 5 Januari 2015 itu artinya adalah 6 Januari, dan kalau juga 2 steps maka 7 Januari gitu. Oke, jadi seperti yang sudah saya bilang tadi, untuk melakukan prediksi menggunakan analisis time series serial dependence, features data kita perlu untuk memiliki jumlah n leg data yang optimal untuk dimiliki. Nah, bagaimana cara kita menentukannya? Kita akan memplot sebuah partial autocorrelation menggunakan fungsi plot PACF yang kita import pada ini. Oke, jadi berikut ini adalah partial autocorrelation yang sudah kita plot, dan cara kita untuk membaca visualisasi ini untuk menentukan berapa n leg data yang optimal dimiliki oleh features data kita adalah sebagai berikut. Jadi kita melihat kapan nilai pada sumbu Y ini masih berada di luar shades ini, which is shades ini adalah 95% confidence interval dari partial autocorrelation kita. Nah, di sini kita lihat ternyata pada saat leg-nya sebanyak 2, ini terakhir di luar shades. Jadi kita akan memilih sebanyak 2 leg data untuk features data untuk high stock price kita. Nah, dengan prosedur yang sama, dapat kita lihat bahwa ternyata pada saat leg 2, ini adalah nilai leg terakhir yang masih berada di luar shades gitu. Berarti kita akan memilih sebanyak 2 leg data untuk melatih machine learning model kita untuk data low stock price gitu. Oke, jadi selanjutnya kita juga akan melakukan membuat beberapa fungsi. Fungsi yang pertama akan kita buat adalah fungsi make legs. di mana fungsi ini tujuannya untuk membuat data frame untuk digunakan oleh features data kita yang akan memuat sebanyak n-like data yang kita tentukan dari partial autocorrelation tadi. Selanjutnya, kita akan membuat sebuah fungsi make multi-step target, di mana fungsi ini tujuannya untuk mengenerate data frame yang akan digunakan untuk targets data yang nantinya akan memuat sebanyak n steps data. Jadi, jika kita ingin memprediksi sebanyak 4 hari ke depan, itu artinya kita perlu membentuk sebanyak 4 steps data. Begitu. Selanjutnya, kita akan membuat sebuah fungsi plot multi-step, di mana fungsi ini akan memvisualisasikan prediksi yang dihasilkan oleh machine learning model kita. Gitu. Oke, dan terakhir, kita akan mengenerate and plot serial dependence model. Nah, fungsi ini tujuan untuk memvisualisasikan serial dependence model bergantung terhadap model strategi yang akan kita gunakan. Jadi jadi pada analisis time series serial dependence, kita dapat melakukan analisis ini menggunakan berbagai macam strategi, di mana pada program kali ini kita akan menyampaikan 3 strategi yang biasa digunakan. Strategi pertama adalah multi-output model, kemudian strategi kedua adalah direct strategy, dan strategi ketiga adalah direct strategy, di mana masing-masing strategi ini tuh akan memiliki algoritma yang berbeda-beda untuk melatih machine learning model mereka. Jadi kita akan karena program yang digunakan tuh alurnya sama, kita hanya perlu mengganti modelnya sesuai dengan algoritma yang sesuai dengan strategi kita, gitu. Oke, jadi penjelasan singkat terkait fungsi adalah pertama, kita akan membuat features data yang akan disimpan ke dalam parameter X, ke dalam variabel X, menggunakan fungsi makeLess yang sudah kita buat. Selanjutnya, kita akan membuat targets data menggunakan fungsi make multi-step target dengan fungsi yang sudah kita buat. Kemudian, dari features data dan target data yang sudah kita miliki, kita akan membagi data itu menjadi 75% training data dan 25% testing data. Kemudian, kita akan melatih machine learning model kita menggunakan training data, dan selanjutnya kita akan membentuk prediksi baik dari features data dari training data maupun dari testing data ya. Kemudian, kita akan menghitung RMSE baik dari prediksi yang dihasilkan dari features training data maupun dari testing training data. Dan rangkaian kode ini digunakan untuk memvisualisasikan hasil prediksi yang dihasilkan oleh machine learning model kita. Oke, jadi seperti yang sudah saya bilang, ini pertama adalah strategi serial dependence. Pertama yaitu adalah multi-output model strategy. Oke, jadi pada strategi ini, algoritma yang akan digunakan adalah linear regression gitu. Jadi kita akan menyimpan algoritmanya ke dalam sebuah variabel, dan variabel ini akan kita pass ke dalam fungsi yang sudah kita buat. Nah, di sini kita forecast sebanyak 4 hari ke depan. Jadi dan ini adalah hasil visualisasinya. Nah, di sini dapat kita lihat bahwa ternyata training RMSE itu 65 gitu, which is gede banget, 3 kali lebih besar dibandingkan yang seasonality time series sebelumnya gitu. Dan kita juga dapat lihat ternyata prediksi yang dihasilkan itu kurang dapat menyamai actual data yang kita miliki gitu, baik dari training data maupun dari testing data. Bahkan testing datanya cukup tinggi ya, 136 gitu. Jadi kita masih belum dapat menilai bahwa strategi ini tuh optimal untuk digunakan untuk melakukan forecast gitu. Selanjutnya kita akan lanjut ke strategi yang kedua, itu adalah direct strategy, di mana algoritma machine learning yang akan digunakan itu adalah XGB regressor yang diberikan sebuah wrapper yaitu multi output regressor. Nah, dan berikut ini adalah hasil prediksi yang dihasilkan. Di sini dapat kita lihat bahwa training RMSE-nya itu 27. Which is lebih kecil daripada yang multi output model gitu. Namun testing RMSE itu masih lebih besar gitu, masih cukup lebih besar daripada training RMSE-nya. Jadi di sini kita dapat lihat bahwa kemungkinan ada terjadi overfit dari machine learning yang kita hasilkan. Selanjutnya terakhir, di sini adalah strategi direct model strategy, di mana algoritma yang digunakan adalah XGB regressor dengan diberikan wrapper regressor chain. Di sini dapat kita lihat bahwa prediksi yang dihasilkan itu RMSE-nya tuh 33 dan testing RMSE juga masih lebih besar daripada training RMSE-nya. Jadi walaupun ini lebih baik daripada multi output model, tapi masih lebih buruk dibandingkan yang direct strategy gitu. Jadi kita dapat menarik kesimpulan bahwa dari ketiga strategi ini, strategi direct strategy itu lebih baik dibandingkan multi output model maupun direct model strategy. Nah, jadi tadi kita sudah menjelaskan masing-masing program yang dapat kita gunakan. Untuk pertama, melakukan analisis time series menggunakan pertama trend line, seasonality, dan serial dependence. Nah, dari masing-masing metode ini kita memiliki kelebihan dan kekurangannya masing-masing. Dan jika kita dapat menggabungkan masing-masing metode ini untuk membentuk satu prediksi yang sama, maka dari itu kita dapat membuat sebuah prediksi yang memiliki akurasi yang lebih baik dan tentunya forecast yang dapat lebih tepat memprediksi data-data beberapa hari ke depannya begitu. Oke, jadi sekian dari program yang dapat kita gunakan untuk melakukan analisis time series. Saya kembalikan kembali kepada Pak Ray. Terima kasih.
Oke, thank you Mas Arya. Saya balik lagi ke sini ya. Oke, tadi udah dijelasin ya. Jadi ada multi output, ada direct, ada rekursif. Terus tadi yang di demoin terakhir adalah gabungan ya, direct sama rekursif atau direct jadi ya gabungannya. Dan ini ngingetin aja karena kita ada di ML Study Jam. Jadi nanti usahain setelah ML Study Jam ini teman-teman yang hadir di sini bisa ambil digital badge-nya gitu ya, ikutin di Kaggle, terus complete challenge-nya, terus ngambil sertifikasinya. Terus kalau udah, siapa tahu teman-teman di sini ada yang tertarik untuk lebih mastery lagi ya di dunia machine learning gitu ya, di Kaggle ataupun di Google-nya sendiri banyak challenge dan bisa ambil sertifikasi juga, baik itu dari TensorFlow ataupun ambil GCP/ML Engineer Certification. Dan hopefully dari teman-teman yang hadir di ML Study Jam hari ini ada yang bisa jadi GDE nih, kayak Mbak Indra ya di GDG Surabaya. Gitu, mungkin itu aja. Thank you. Kembali ke Mbak Isti. Kita buka pertanyaan atau mungkin langsung ke sesi kedua. Silakan.
Oke, terima kasih banyak atas materinya yang sangat luar biasa dan menarik ya Pak Ray dan tim. Anyway, karena waktunya udah habis, kita langsung aja ke sesi 2 gitu. Terima kasih Pak Ray dan tim.
Sama-sama.
Oke, kalau gitu langsung aja ya. Untuk second session ini we'll be discussing about building a career in artificial intelligence, the pathway to working as a tech employee, in machine learning and AI. Nah, anyway, our speaker is Mr. Sam, which is a Google developer expert in machine learning. He is also experienced in both technology and business development. So, hello, Mr. Sam.
Hello, how are you? Can you hear me?
Yeah, I can hear you, Mr.
No, I didn't get a chance to test my mic and stuff, so good that you guys can hear me. Let me just share my screen. I don't speak Bahasa, so I didn't get to understand everything, but it sounded very cool what you're learning with the XGBoost and stuff there. Can you see my screen?
Anyway, Mr. Sam, the time and place is yours, yeah?
Okay. Just quickly, so hang on, let me just try and bring up the participants so I can see stuff a little bit. So is this, so you've done 4 sessions from what I understand. How many of you have done machine learning or deep learning before this course? Maybe if you put your hand up on Zoom. I'm just kind of curious to see, can people put their hand up? Yes, okay, so at least someone's done it. Okay, so is everyone new? Everyone else is new to the field? I'm guessing, yes? Okay. All right, so today I'm going to talk a little bit about building a career in AI. I'm conscious that you guys are all students from what I've been told, and studying hard and stuff like that. Can I get a show of hands? How many of you are doing like a computer science degree? Anyone? No one's doing computer science or a technical degree? Okay, some people doing it, right? If you have trouble understanding me, please send me a message or something so that I can speak a bit slower, that kind of thing. Okay, so it seems like some of you are doing computer science and stuff like that. What I'm going to try and talk about is, rather than do more technical stuff, because from what I've seen, you guys have done technical stuff for the past few sessions. Today, I'm going to talk a little bit more about what you should be thinking about to build a career going forward in AI. And this is an area that's changing very, very quickly. So a little bit about myself. So I was one of the first Google developer experts for machine learning appointed, one of the first 10 in the world. I co-organize, at the moment I'm based in Singapore. So I co-organize the machine learning meetup in Singapore. I work on deep learning for language and dialogue systems, specifically things to do with conversational AI, generative models, that kind of thing. I also do a bunch of research for that, which I'll talk about when I talk about the company that I'm working with at the moment. And also I'm one of the Google startup mentors for Asia and for the United States around AI and things like that. In my past, I've built multiple startups. I've built 2 startups with more than 1 million users. And the current startup that I'm building is a startup called Red Dragon AI, which we started in 2017. So we're a Google partner. We do a lot of research. So we've had papers at all the sort of main AI conferences, NeurIPS, ImmuNLP, NACL, these kind of things. And a lot of our research is around conversational systems and generative sort of things to do with faces. So we're working on virtual people is one of the key things that we're sort of working on. So what I wanted to do today, so I've been, I guess I'd give you a little bit of background too. I've been working in AI for probably close on 10 years. I've worked in deep learning for about a bit over 8 years. So I've seen a lot of things change in that time. Even though it's a reasonably short time, things have really exploded. So what I wanted to talk about today is to give you 5 tips for building a career, right? Rather than go technical. I'm happy later on if people have questions to ask me technical questions or anything like that. That's cool. But what I wanted to sort of just talk about was get you thinking about, if you want this to be your career, what do you do when you're 21, 22, 23 years old to project out to have a long career in this? I'm going to tell you that, it is very, this industry is very, very new, right? In the going wide. So there are lots of opportunities for you guys to have careers in this. Everybody's looking to hire people for these kind of skills. But I want to sort of like get you focused on what are the skills you need to have and what you should be doing to sort of prove that you've got those skills. If people have questions at any point, please feel free to basically just ask me in the chat or something. Like I said, I can't, okay, so I've got the chat open. I can't read Bahasa, but if you write it in English, I can probably work it out. All right, so the first thing I wanted to talk about was sort of real AI people versus fake AI people. So this is something that I've seen in the past 6 months to 1 year, right? Is that there are lots of fake AI people out there. And I'm not talking about deep fakes and stuff like that. I'm talking about people who pretend to be AI people and try to make a living out of it or try to be commentators about it, but they don't really know what they're talking about. So I want you to be very wary of people like this. You see a lot of people like this on LinkedIn. So I've hidden who these people are. But you will see that they post things like, oh, this cool new demo or this cool new thing like that. And there are lots of people like this, right? I don't want you to be one of these people, right? The thing I'm trying to get through to you today is be the people who do it, not the people who post it on LinkedIn as a nice picture or as a video. There's no reason why you can't be the ones that do it. This is the big thing I want to sort of impress upon you today. So look out for these kind of commentators. You see them a lot now on social media talking about AI and stuff like that. And maybe they've got some expertise, but they're not the people who are sitting down and coding it, right? Watching the last presenter, as I came in early, he's going through code, right? That's good, right? That's what we want. We want you to focus on code. We want you to focus on how do I make this work? Not just, oh, look, there's a pretty picture. So I'm guessing many of you know like DALL-E, that you've seen the DALL-E 2 things or something like that. So you see lots of people posting pictures of that online now, like of the AI art and claiming to be AI, but really they're just typing something into a website and it makes a picture, right? They're not doing the coding for it. There's no reason why you can't be the one who writes the code. This is what I want you to sort of stress. So the other thing too is to be wary of is what I call fake AI people who are teaching these courses where they're like, oh, you can learn TensorFlow 2 and become a master in 15 minutes. And then next week it's 10 minutes. And then the week after it's 8 minutes, right? It doesn't work like that, right? It's not, don't fall for this kind of thing. The last one I would say is, are the doomsday people. So there are a lot of people out there saying that, oh, AI is going to mean the end of the world. And these two pictures actually are from real media sites in the United Kingdom, in England, that was talking about one of Google's new algorithms about 4 years ago, right? And they actually had these pictures, right? So what I would say is, don't buy into the hype around things like that, right? Don't become one of those. What is a real AI person? So for me, a real AI person is someone that knows how to code, someone that, researches papers or at least reads to understand some papers and stuff like that. They realize that AGI is not here next week, right? That your XG boost is not going to grow up and kill you and, and do all these sorts of things, right? It's that building stuff that improves the world. And this is especially important in countries like Indonesia and in this area of Southeast Asia, right? We've got lots of people and there's lots of opportunities for AI to make people's lives better. And a lot of that is going to come down to people like the people on the call today, right? So this is what I want to sort of get through to you. All right, so the first tip I would say is get started. So you all have done that, in this course, right? And hopefully some of you will realize, oh yeah, I really like machine learning. Right. I know for me, when I first, discovered machine learning, I just thought it was really cool, right? That you could sort of teach rather than program something, step by step, you could teach it and then it would learn and you give it data and then it would, build up and do a whole bunch of different things. So I think a lot of you are going to be at that stage now. What you want to do is sort of, take that and run with that going forward. So really the best time to start was yesterday, right? The sooner you start, the better, right? A few things I will say is that the AI boom though is just starting. So I hear a lot of, students ask me, oh, Sam, is it too late to get into AI? Because I see that Google's already done this and Google's done that. No, it's not too late, right? When I got involved with Google, there was probably maybe, we're talking maybe like 100 to 200 people inside Google that knew how to do AI stuff, right? The number was very, very small. Now it's growing, exponentially. In fact, I'll show you that in a second. But what I want you to realize is that that's the same all over the world. So there is a need for people with these skills. It's going to get much bigger. There's going to be plenty of job opportunities. And, everyone has to start from somewhere. All right. So the other thing I would say to you too is that, and maybe I'm going to show you this in slides later on, don't think because you're in Indonesia or you're in a smaller town or something like that, that you can't do this. All the resources nowadays are online. If you've got an internet connection, if you can watch YouTube, if you can do, log into Kaggle, if you can read, the papers and stuff like that, you can do just as well as, as anywhere. It's interesting because I think most of you are in Surabaya, is that right? Maybe I'm wrong. But I remember like there was a couple of years ago when I was studying GANs a lot. There was actually I forgot his name. I should have looked up his GitHub account. Well, it's a GitHub account from a guy in Indonesia who was doing a lot of cool things with GANs. And I would look at his code and say like, oh man, this guy is really, this guy's really cool. And then I think I found out later on he was doing a PhD there or something. But my point being that like, if, of course, if you asked me to guess, I wouldn't have straight away said, oh yeah, that's where he's going to come from, or this GitHub account is going to come from. But what I want you to realize is that that doesn't matter, right? You can be someone in the middle of the nowhere and contribute to the top tiers now, right? This is something that's really cool. To show you sort of the explosion, here's a picture of, so you all know GitHub. I'm guessing everyone knows GitHub. So inside Google, there is their own sort of internal repo system. Not GitHub, but it's something like, an internal Google thing. And this shows you the number of repos in there that had deep learning code. And you can see that in sort of like 2012, there were tiny amounts of these repos where they're trying things out. And, by sort of 2014, when I started getting involved with deep learning, it was still tiny, right? Even just over the next 3 years, it exploded. So you can see Google, TensorFlow launched internally inside Google in the third quarter in 2014. Before that, they used to use a framework called Distill Belief, which was their internal thing in C++, but they moved to TensorFlow, and then sort of like at the end of 2014, TensorFlow got released publicly as open source. And you can see this exploded. And here's the thing is that you're seeing here it go from sort of 0 up to 4,000. I can tell you that there isn't a single product now inside Google that doesn't use machine learning and probably doesn't use deep learning. Whether we're talking about recommendations in YouTube and Google Play, whether we're talking about voice on Android, whether we're talking about predicting smart reply on Gmail, all of these things are using deep learning for doing this kind of thing. So I want you to see that this explosion is something that's happening as we're sitting here, right? It started, 5 years ago, yes, or more, but it's still growing bigger. And here's the thing, it's not even just Google. So if we look at the sort of explosion of models and model sizes, the original ideas for a lot of the machine learning stuff started back in, and deep learning ideas started back in sort of 1960s and took off in the 80s. And you can see that there was a big change around about sort of 2012, where people started to then have the compute, the data, and the algorithms. In the past, they had the algorithms, but they didn't have the compute or the data. So that's one of the things that, that really changed. And you can see that AlphaGo, I'm guessing many of you have heard of AlphaGo. That's the model that DeepMind made to play Go, and was the first model that really beat humans at a game that people thought would be impossible for a computer to beat humans for at least another 10, 20 years. So that happened, sort of around 2017. Since then, it's exploded even more. So we jump forward to sort of 2019. You can see that starting out in sort of 2017, 2018, a big model was like in the millions of parameters. So if you had a model that was sort of like 100 million parameters, that was like a huge model, right? By sort of 2019, we had GPT-2 come out, which was 1.5 billion parameters, was huge, was so big that back then they said, oh, it's so dangerous, we can't release this code or anything like that. Within a few years, that became nothing, right? We saw like NVIDIA release models, and then more recently, in the past 2 years, we've seen the models go from sort of like 100 million to a 1.5 billion to GPT-3 being 175 billion, so an order of magnitude, a couple of orders of magnitude bigger there. Gopher was a model inside of DeepMind that was 280 billion. And we've even got models now up into the trillions of, parameters. So Wudao 2 is the one in China. The one that's probably the most interesting one at the moment is this model Palm, which not only is big, but it's optimized in a very special way to actually make it better than a lot of the even bigger models that are out there. But what I want you to see is this explosion going on, right? And it's not just Google, it's not just the research companies. In industry, we're seeing, people doing stuff with computer vision, wanting to find things in pictures, describe things in images, looking for similarities, like all these sorts of products are taking off. In structured data, people are using it for a whole bunch of different things that 10 years ago, people wouldn't have dared use machine learning for this stuff, but deep learning now has made it so, effective in this. Probably in the last 5 years, since the launch of the transformer model, we've seen this explosion in natural language processing. There's a bunch of really interesting models now for not only for translation, but for things to do with sentiment, for things to do with classification, a whole bunch of different things like that. And obviously, chatbots and more advanced conversational agents that have come along as well. So this is something that, that's taking off. So the best time to start was yesterday, right? If you didn't start yesterday, then get moving, as quickly as you can today going forward. So that's sort of tip 1. Tip 2 is get good, right? And what I mean by this is that, to be honest, it's in some ways it's easier today, and in some ways it's harder today, right? It's easier because there's 1,000 times more resources than there were, before, right? When I started learning deep learning, I can remember we would get excited if there was one article on the internet every week about, deep learning, right? Now there's probably at least 100 to 200 a day that are coming out, and people are writing, if you look at medium.com, people are writing tutorials and stuff like that. There's plenty of material out there. But it's also the standard is going up, right? There's a lot more things that you could do. When I first started out, you didn't need to specialize. You could kind of know a bit of everything and be able to put it together. Whereas now more and more people are starting to specialize for this sort of stuff. So let's look at some of this stuff. So I would say all of this stuff can be learned, right? That's the baseline that you've got to believe in this, right? Is that, okay, this is something you can learn, right? It's going to be hard at the start, yes, and most people will give up. I say that, you need to understand it's not easy for anyone. So if you went through this course and you thought, wow, I don't understand how does he come up with those, those settings for the XG boost, or how does he do this and stuff like that? And at the start, you're going to be like confused. You just got to jump in and try and do your best, right? And then the more that you do it, the better you're going to get, the more you're going to find yourself, realizing that, oh, okay, I start to understand this now. I start to understand what this parameter does, or what this bit of the code does, and things like that. Don't punish yourself, and don't think that, oh, I have to know every single part of it today, because you're not going to. Right, that's one of the key things that I want to sort of stress a lot. You really need to understand that this takes time, right? Even if you were the smart kid, and I'm sure a lot of you were the smart kid in primary school or high school, and now you've come to this, and it's like, wow, this is hard, right? Yes, it is, but it's worth persisting with, right? That's what I would say for you there. What to learn. So let's talk a little bit about, what to learn. The number one thing that you probably, focused on a lot, I think last week when you did transfer learning and maybe some of the other days, are classification models. So if you look at this picture, obviously some of these are chihuahuas, some of these are blueberry muffins, right? The funny thing is that this is harder for a human. It takes longer for a human to work out whether it's a muffin or whether it's a dog than it takes for a deep learning algorithm. This is a super simple task for a deep learning algorithm, but it's a simple, it's a classification task, right? It's saying, is this a picture of this or is it a picture of that? And the same is true for text, right? Is this, if I'm building a model to decide what, one of the things that I consulted with one of Google's customers on was a very big company, and they decided they wanted to have one public email address. So it was like hello@companyname.com. Now that sounds really nice, right? Their marketing people were like, okay, of course everyone will still have an email address inside the company and stuff like that, and they can get email from outside people, but whenever someone contacts the company, we just want one email address. Now you think about it, the problem with that is that some people are going to send emails about sales, some people are going to send emails about support, some people are going to send emails about, HR and stuff like that. So what we consulted with them on was building a model that read the email and then classified it as either a sales email, a marketing email, a support email, so it would decide which department it sent it to. And that's a classification task. So you have classification tasks for lots of different things. These are still the bread and butter, or these are still the main tasks that you're going to see for anything, whether you're talking about computer vision, whether you're talking about tabular data, whether you're talking about NLP, this kind of thing. So get good at this, but realize that where 10 years ago, this was kind of like the only task that deep learning did, and maybe regression as well. Now, things have gone way beyond this. So the next kind of models would be segmentation models and object detection models. So you can see here, now the model is not just saying, is this whole picture a cat or a dog? It's saying, all right, is this pixel? So this is technically still like a classification task, but it's a classification task at a pixel level. So now we're looking at each pixel and saying, is this a pixel of a traffic light or a pixel of a car? And so the model's learning to be able to look at everything around it and be able to then segment things or to detect objects and things. This is now one of the biggest tasks that you see people using computer vision for, to find things in images and detect where they are. We've seen really amazing things, for example, in the war in Ukraine, that they've been able to do really well with just drones that can fly around above and then spot, Russian tanks or whatever, way quicker than humans could, and can say, right, there's, this truck here, there's this tank here, there's this, satellite here, this kind of thing. So this is a big one that you sort of see. Another one now that we're seeing a lot more is image captioning models. So this is a model from Google. This is a pictures from Google. And you can see that here, this is given the image, it basically says that this is a person on a beach flying a kite, right? Now, it's trained up with hundreds of thousands of images to be able to do this. And this one is probably from about 2017, 2018, this particular picture. You can see that even though we can't see any string between the person and the kite, it can work out the fact that they're looking at there's a high probability that they're the person flying it. Notice it doesn't find the boy at the bottom. You see there's a boy or girl or someone lying down there at the bottom. It doesn't pick that up, right? Because it probably didn't have enough training examples or anything like that to know. But it definitely knows that it's a beach. Definitely, it definitely gets that this is a kite, not a bird. It's done pretty well in that sense. So these are some of the things that, I want you to sort of look at. So you want to start asking yourself and getting yourself to build these things, right? You want to learn and build along the way. So I'll show you some of the things that I built in research and stuff like that early on that go beyond just classification. So once you get good at classification, classification is great for things like Kaggle competitions and stuff like that, but you then want to learn to go to more advanced stuff. So generative models are the sort of big thing, one of the big areas nowadays. So this particular model was a thing that I trained in 2017. And you can see that on the left, the top one is what we call a super resolution model. On the left, we've got a low resolution input. And then the model predicts this higher resolution output. And then the one on the right is the ground truth, the real picture. So you can see it's pretty close to what she looks like. Certainly a lot better than the blurry input that we put in. Right now, to train this was trained on about 200,000 images. And it's certainly not perfect. You can do much better nowadays. But for the time, it was, this was state of the art. The sad thing was, like, when I did this, I showed this to my wife, and I was like so happy that, like, this was like state of the art. I worked out how to do it, stuff like that. I showed it to my wife, and my wife was like, "Oh, they do that on TV all the time." Right? On all the detective shows, they just zoom in and they can do it, right? And I was like, yeah, no, but that on TV is not real, right? This is real. So this is the kind of thing where you should be looking at, like, how do you build some of these models? The exact same model, it turns out, can be used for going from black and white to color pictures. So this is the exact same architecture of model. And this is going from black and white photos to color photos. And you can see this is the ground truth on the right there. It actually fixes up the color. You notice that this is what we call warm light, where it's like a yellow, the light is kind of warm yellow, and it actually makes it look yellow, even though we kind of know that it's a white background there. Like, this is not painted yellow. And the model learns over so many images that it can actually fix that up. This is the kind of model that is in your phone, right? If you've got an Android phone with like a photo app and stuff like that, this is one of the models that people used for a long time in those kind of things. Another example of doing a real world project that is taking these skills and just taking them to the next level this is the thing I did in 2018 of where we had a Google customer who wanted to be able to scan ID cards in Thailand. And so this is the Thai ID. You can see here. What they were, there's a lot of information there, right? You can see that actually in the end, the model does very well at getting out all the information. It predicts whether this person's male or female. It gets their birth date. So even when their birth date is missing, which was one of the problems that we had with Thai ID cards, sometimes they don't know their actual birth date. So we'll just have the year. It gets the address. It gets all of this data. So to do this, this was something that even inside Google, they didn't have OCR for Thai language at that time, right? So you can see that Thai language is very different in the script. So there are 77 different characters in Thai. One of the things that was like, okay, how do we approach this? So what I kind of worked out was, well, really what we want is data, right? We know that for this kind of thing, we want a lot of data. So you need to learn to make data sets. This is one of the things that I'm going to sort of impress upon you next, was, how do you make your own data sets? So it turns out for this Thai OCR thing, and I also did one for Thai handwriting, what I did was I found just bunches of Thai, all the Thai fonts I could get. And then I basically used a scraped version of Thai Wikipedia. And we started off just doing one word at a time and training a word to do one word, then do 2 words at a time, then do 3 words at a time, then do 4 words at a time, etc. And to get this model working pretty well, so this is actually saying Singapore in Thai here, to get this working well, it took sort of about, I think, 600,000 examples of handwriting, to be able to do it. But because I put the effort into writing the code to make the data set, because I could just basically print it out in Thai, and then I had what it should actually be. I had the data to be able to make it. So this is one of the things I want to impress upon you too. You often need to learn to get good at data. Both understanding it, but also making it, learning how you can, find or create data to train models on, different strategies for that kind of thing. And I've just scratched the surface here, right? There's a whole bunch of different things, kinds of models, speech recognition, question and answering systems, recommendation systems, anomaly detection, all these different things. You need to start to learn some of the more advanced things, not just the classification, is what I'm trying to say to you here. It may be that you decide for yourself that, well, okay, I'm going to specialize in NLP. And that's cool, right? Then you have to go through all the different kinds of NLP models. Again, NLP has classification, has question and answering, has, OCR, has all these sorts of things as well to think about. Really what, when we look at sort of research versus implementation, what industry needs at the moment are people who can implement things. So they can look at the research, they can learn how it works, and then they can find the real world data or make it into some kind of product, right? There are lots of jobs for people like this. I can tell you that, the companies are always looking for people like this, where they can basically find people that can implement papers, that can implement different techniques to turn these into products. One of the things that we've found over the last 5 years is that almost always, if you take deep learning plus domain expertise, you get state-of-the-art results. So one of the things that in teaching, we've taught a whole bunch of different people, and sometimes they've got skills that we know nothing about. So we had one person go through one of our courses that what his job was he's a scientist that studied bacteria. And he basically had pictures of bacteria. And what they would do is they could take the bad bacteria and stain it with a fluorescent dye, so that they could then check, which was the bad bacteria and which was the good bacteria. And it would only show up when you put a black light above it. What he did was make up a data set of that, okay, this is the non-black light version, this is the black light version, and then teach a deep learning model to just look at the non-black, the non-fluorescent one and predict what was the bad bacteria. And sure enough, that became a state-of-the-art technique, right? And being able to just take a photo and then give it to a deep learning model, and it could predict whether there was bad bacteria here or not. So this is a thing that I've seen again and again and again, is that with things like solar panels. We've had people go through where they were in a factory, they had problems determining, is there enough solder on the solar panel to make it work? And is it set up properly? And sure enough, their domain expertise of making a data set plus the deep learning skills would turn out to be state-of-the-art results. So what do you need to know the basics, right? So I'm talking about that you need to jump in and do some of these advanced things, but some of the things that I want you to remember are that all these models have the same components that you should be thinking about. All of the models basically have what I call the 4 building blocks. Someone got their mic on? I can hear someone's mic. Okay, I think that's better. So all the models comes back to the building blocks, right? Every model, if you're confused about how a model works or something like that, just go back to the building blocks. Ask yourself, what is the inputs? What is the outputs, right? What are the architectures, the losses, the optimizers? And hopefully you've learned some of these in the sessions you've done. We've got, model inputs. They can be all different, but at the end of the day, you've got to convert everything to a number, right? We're doing mathematics at the end of the day. So that can be vectorized data, can be images, even things like audio get converted to spectra to be processed. You've got sequences, a whole bunch of different things that, like that. You've got the architectures, which are the ways that we set up the different models. So they start out with simple models like fully connected models. They go to things like convolutional neural networks, which I think you did last week. And then you've got things like recurrent networks. And nowadays, the big one is transformer networks that people use for these kind of things. But again, ask yourself, okay, out of this kind of technique that I want to learn, which model does it use here? And if you've learned the basics of these and you understand how they work, you can start to get a handle on the more advanced stuff. You can think about the architecture is like the engine, and everything that you're doing in there is tuning that engine, right? Just to make it better. Losses. So I don't know how much you guys have talked about losses and how much math and stuff you've done in this course. For some of you, you might look at the math and say, oh, that's really easy. For some of you might say, whoa, okay, I'm a bit confused. What I would say is that if you understand the loss is just basically what's making the model get better or worse, right? Is the loss function that we're using. You find that in the frameworks, the losses are actually done for you most of the time. So you can see here in TensorFlow, we've got TensorFlow-Keras.losses, and then we've got like categorical cross-entropy loss here, which is a common one used for classification tasks. Here you might have something like mean squared error loss. But again, in the frameworks, in the code themselves, these are actually pretty easy. Also, in the frameworks, optimizers are pretty easy. So the math behind optimizers can get very complicated very quickly. But again, in the frameworks, you find that these are often going to be one line of code where you're going to use a pre-built optimization function already. Hopefully, you guys know what a loss function is and then what an optimizer is, right, from going through this course. I don't have a lot of time to sort of, go through that, but those two, even though people don't talk about them a lot, as you get more advanced stuff, you'll end up playing a lot more, especially with losses of different, losses. The losses and the optimizers are what sort of keep you on track to getting where you want to go. So if you take off, at Newark Airport here outside of New York, and you want to get to Singapore, actually, it turns out that the plane is off course, 90% of the time, right? It's constantly going left, right, left, right, left, right, like that to get here. Now, obviously, it's very fine changes. And a machine learning model is the same. You're doing lots of fine changes to get from where you started to where you want to be. All right, so skill stacks that you should be looking at. I'm presuming that most of you know coding. I'm not sure about that. What situation you are. You need some basic coding. You need statistics and data science. You need machine learning. All right. The math behind a lot of this, eventually you will need to understand it. At the start, though, don't freak out if you don't understand it. Just keep going, with learning the concepts themselves. So if you're new to programming, definitely Python is where you want to get started. The funny thing is, to do machine learning, you don't need to be a great programmer. The code related to machine learning is actually very simple, and there's not a lot of it, right? So you're really learning to code for this data stuff. The data science stack in Python is where you probably want to focus. So you really want to focus on learning these frameworks, right? Of knowing things like NumPy is the numerical computing library in Python. NumPy is becoming more and more important. It's probably one of the oldest Python libraries. It comes from the 1990s. Pandas is a library for doing sort of Excel things and data frames on with code. Scikit-learn, I saw you were doing that already today, so hopefully you guys understand, what Scikit-learn is. And then you've got Matplotlib, stuff like that for doing visualizations. These are sort of the basic ones. When it comes to deep learning, there are lots of frameworks out there. And to be honest, a lot of these frameworks have either died or are dying, right? So I would say that out of these frameworks, there's really only two that you need to focus on at the start. You want to sort of know a bit about TensorFlow and Keras, and you want to know about PyTorch. Later on, the new one that's sort of that's coming up very strong is JAX. Right, so JAX is a new framework. TensorFlow is made by Google. Keras was a framework that was a high-level framework that was around before TensorFlow. Was for a thing called Theano. It now basically works just with TensorFlow. It gives you the high-level abstraction. So I'm guessing this is what you probably used last week for the transfer learning. Is that right? Just nod if you guys, did you guys use that or did you use PyTorch? I'm curious, did you use TensorFlow or PyTorch? Which one? TensorFlow, okay, cool, all right. And then some people are using PyTorch as well. Okay, that's great, right? Either of these frameworks is great. I probably use more PyTorch now than I use TensorFlow, and I actually use JAX a lot more now as well too. JAX is definitely a research framework. And it's actually based on NumPy, right? So this is where I said, NumPy is what, really, you need to understand that. A lot of ideas from PyTorch are also based on NumPy as well. So they're things you definitely want to know. But don't waste your time with these other frameworks, right? MXNet, I think, was originally from AWS. They've closed it down. Theano and Caffe, they're long gone. CNTK was from Microsoft. They've closed that down. Torch is actually the sort of precursor to PyTorch. Torch has been around for a long time. It was written in a language called Lua, which is, you do not want to get involved with that, right, in this day and age. And then so really what I would say is focus on the sort of TensorFlow plus Keras, PyTorch, and then JAX, right? And it's good you'll find that actually TensorFlow and PyTorch are converging, right? They both sort of, TensorFlow was first, PyTorch came along, they copied a lot of ideas from TensorFlow, but then they also came up with a lot of good ideas themselves. They copied a lot of ideas from a framework called Chainer, which was a really good framework. And then now TensorFlow has copied some ideas back from PyTorch kind of thing as well. You'll find that these frameworks kind of are splitting off into different ways of thinking. So at the moment in industry, you probably see TensorFlow and Keras more than you see PyTorch, but that's changing. PyTorch is actually coming along very strongly in industry as well. But definitely PyTorch and JAX are the ones that people are using for research nowadays. So like I said, once you learn one of these, it will literally just take you a weekend to learn the other one. And there'll be some things that are different that you have to go and look at the docs, but you'll find the majority of the ideas are the same. You've got those building blocks of your inputs and outputs, your architecture, your loss function, your optimizer function. TensorFlow is kind of good because it has a whole ecosystem around it. That's with things like TensorBoard, TensorFlow Lite, if you want to build something to put it on a mobile phone, TensorFlow JS, if you want to put it in a browser, TensorFlow Extended, if you want to build pipelines for the cloud and stuff like that. PyTorch is starting to have some of these. I think they've got Torch Mobile now. They're coming along, but they're probably 1 or 2 years behind. But they probably will catch up very quickly, I would say, for these. So that's step 2, right? Is get good at these things. And this is by far the longest one that I'm going to talk about, today. The next thing I would say is you've got to get confident, right? And I have cats at home. I don't have any of the cats in here. Normally you'll see them walking around my office, but these are my 2 cats. And they, cats start out really sort of shy and a bit scared when they're very young kittens, but very quickly they start to get confident and they try new things and they, constantly, I'm sure you've all sort of seen things like that, right? So you need to be the same. You need to get confident at building. So do lots of little projects, build lots of, little things. Often, I'll just see something and I'll think, oh, how would I build that, right? And I'll just put, often maybe while I'm watching TV or something, I'll start to code out some ideas or something like that and just see like, oh, would this work or would this not work? Not because I'm necessarily going to turn it into a product, but I just want to try it out and see. The other thing is you want to work with other people on projects for things that, are going to become bigger. So join, other people's projects as well. When you get better, then you want to start reading papers and you want to implement papers. So at this stage, you're now sort of looking at a paper as a diagram for a model. And how do I take this, diagram and turn it into code? And that's hard, right? It's not easy. So you want to start with easier papers and gradually work up to, to harder and harder things. You want to contribute to open source. So as you start to sort of look out there and see, a lot of these frameworks and stuff like that, if you've got a good idea or you've got a model, you can now upload it on things like the Hugging Face, Model Hub. There's a PyTorch Model Hub. There's a TensorFlow Model Hub. There's lots of things that you can do with those things. Another way that you can get confident, which I think a lot of people overlook a lot, is internships. Just by going and working, whether it's for free or whether it's just like a small short-time job or something, where you actually have to work on something real, and then someone can give you feedback about, okay, you coded this maybe not great or that kind of thing. One of the things you can do is, I should put a slide in here. There's a thing called Google Summer of Code. How many of you know that? How many? Just put your hand up if you've heard of that. Google Summer of Code. Okay, I'm only seeing 1 or 2 hands go up. So if you're interested, do a search for that and look into applying for it. That basically means that you'll get put on a project. And I've seen, I used to be based in New York, and I've seen when I was in New York that students who did that for a summer ended up getting hired by Google at their end of their degree, the ones that were good and stuff. So that's a path to getting a job and stuff as well that you can sort of think about. The key thing with this thing is remember, your goal at the start is to be an implementer, not a researcher. No one expects you to come up with whole new ways to do things. What they want to see is that you can take something that's out there and make it work for a new data set, for an adjacent task, that kind of thing. Often you will start with an application that you would like to build yourself, and then you'll learn okay, what would I need to do that, right? What kind of models would I need? What would be the things that I need to have for that? The other thing is now, because the way the field is exploding is, at some point you probably are going to be forced to specialize a bit, either in sort of computer vision or NLP or time series, tabular, that kind of thing. I guess you should resist that as much as possible, but realize that, if you've got a preference, go for it, right? If you're really into, hey, I want to do, computer vision models, get out there and start working on those. The cool thing is, whatever you specialize in now, there will be jobs for that, right? There's just not enough people to fill the jobs at the moment. All right, so that's the third one, get confident. Fourth one is get noticed. So I'll go through these two quite quickly, and then I'll take some questions if people are interested. So you want to get noticed, all right? And this is a nice strategy that my co-founder talks about a lot, is this idea of 99-1. And what this means is that 90% of the people just look at what things are going on, right? They don't join in, right? 90% of the people just look. So if you think about like Facebook or social media, 90% of people are just reading the social media. 9% will comment on something someone else did. Like, hey, that's cool that you did this, or, hey, I like that you did this, or can you explain to me why you did this thing, that kind of thing, right? And then 1% will actually be the people who post something new, who write a blog post, who, publish something out there. And it's scary being the 1%, because people are going to criticize you, right? You're going to put something out there, and people are going to see it. And maybe sometimes you're going to get things wrong. You've got to make that jump, right? You've got to try and move from being the 90% to at least being the 9%, and then eventually to the 1% of where you're getting noticed because you're, and the thing is, that could be as simple as putting things up on GitHub. Like I mentioned at the start, I really should have looked at the guy's name. I've forgotten his name. But there was, a guy who was posting all these cool GANs that he was basically just coding up from papers and putting it up, right? And certainly, when I saw it early on, I was like, oh, this is cool, right? And gave him a star, on GitHub or whatever. But when I came back one other time, he had like hundreds of stars, right? So people were noticing him. And that's the thing I want you to get through. I've got a feeling he had a blog, maybe had a blog as well or something. The next thing would be write, teach, make videos, right? This is something that you should try and do. You guys are a group in a place like Surabaya. Okay, I've done a bunch of things in Korea, right? I've gone up and given talks in Korea and stuff like that. One of the things that I've realized is, why does Korea have lots of good deep learning people? One of the reasons is because in their universities, they all teach each other. So the senior people in the university, the senior students, teach all the other students, and then they have paper groups where each person brings on a paper and explains it to other people. And then if if someone gets something wrong, they just, other people say, no, I don't think it's like that, it's like this. And so everyone learns. The more that you can do that by becoming a community leader, that's what you want to do. Right. So this is, really fundamental to sort of everything. And this is, the reason why I agreed to speak today was because, Esther reached out to me and sounds like you guys are doing a lot of cool things there, that kind of thing. Get out and talk. I can't stress enough that giving talks around the world, has been one of the things that's opened a lot of doors for me. So I've given talks at Google, everywhere in the all across the world. I've given talks for NAVA in Korea. I've given a whole bunch of different talks and stuff like that. And just getting out there and doing these things, suddenly then people start talking to you about, hey, would you be interested in getting involved in this project? Or, could you help us with this and stuff like that? If you want to get a job, this is how to get a job, right? People will notice you, and then, you'll get a lot of offers. Becoming a GDE, right? So if you are at the standard where you've been doing all the things we've talked about already, and you're getting things done, apply to become a GDE, right? Google's always looking out for people, especially in places like Indonesia, where we know that, the majority of people perhaps don't speak English. So we want to have local people, being able to teach them in Bahasa, doing things like that, right? So that's something you can think about. So the last tip I'm going to say is rinse and repeat. So, it does get easier over time, the more that you do these things. And you can start to sort of pick up a paper and understand what's going on and, look at someone teaching XGBoost and know what they're talking about and stuff like that. But there's always something new. There's always something coming along. And so you've always got to be updating, for what it is that you're doing. Some resources for you. So I was thinking about this just this afternoon. And so I added this, was like, okay, if you're new to this game, you should understand that like all the papers, most of the papers are going to be on Archive. So Archive is a site. If you just type in Archive papers, you'll see machine learning papers. Whenever you do a search for a paper, that's really good. There's another one, actually, I just thought of now that I didn't put a slide on, called Archive Sanity. Archive Sanity is where you can just type in, hey, give me all the object detection papers, and it will show you a bunch of things like that. So it's also cool. Another site that I love like that would be Papers with Code. So this site is reasonably new. It's like a few years old now. This didn't exist when I was learning, when I was studying out. But this is cool because, one, you can go and see what the top papers are in a particular technique. Two, you can then get the code for those papers, both often by the original author and other implementations. So if someone did an implementation in TensorFlow, you'll usually find someone's done a version in PyTorch. If someone did it in JAX, you might find someone's converted it to PyTorch or to TensorFlow, that kind of thing. And you can also come and browse the state-of-the-art stuff here. So you can actually see examples of what is the state-of-the-art code for this stuff. So if you think about it, the great thing here is none of this is secrets, right? 10 years ago, everything was a secret, right? Meaning that and sort of 15, 20 years ago, especially, everything was a secret. Back in the 1980s and 1990s, when people coded up algorithms, they wouldn't even tell each other, they wouldn't even share the code. So people would write their own code in C++, and there really wasn't much sort of open source going on. So, one researcher would think that their code was the best, and the other one someone would have something faster, and they wouldn't know why. And nowadays, everything's in the open. And people will sort of say, oh, well, this one is faster because of this and this and this. And the cool thing is you can go along and read all this for free. Right? It's not going to, you don't have to pay any money. All this is there for free for you to get. Some other resources I'll give you for tutorials would be Code Labs on Google. The different Code Labs, they've got a bunch of AI and machine learning ones in relation to sort of Google and Google Cloud stuff. Kaggle, which I think you guys know because I think they're involved in what you're doing at the moment, is also a great place to go and learn. Kaggle is a competition site, but the good thing is you can go and look at solutions to other competitions and you can see how people did it. So if you've got something like a time series problem or something like that, you can go along and find a time series competition, just type in time series, and then go and look at all the solutions and see how did they do that and what was the data like. And oh yeah, my data is kind of like this one. And how did people do it? Right? That's something that you should definitely think. And then the sort of last one I would say would be YouTube. YouTube is pretty damn cool, right? With the stuff that's on there. In the past, like I said, when 5 years ago, 5-6 years ago, doing this stuff, you were lucky if you got one article. Forget about YouTube, right? You were lucky if you got one article of someone explaining something online, right? And then gradually it became more and more and more. Now with YouTube, we've got, hundreds of, videos explaining all the latest papers, explaining a lot of stuff like that. So all of this stuff is out there. So what I would say is use these 5 tips. Please understand that you're in the lucky situation of you've got a lot of resources, and if you apply yourself, you can really do well. You're not in the situation where once upon a time you had to go along to Stanford University to be able to learn from the best people and stuff like that. Now you can go online on YouTube and watch all the Stanford courses, right? It's kind of nuts that people are spending $100,000 to go and take some of those courses, and you can go and take a lot of them online for free. So anyway, let me finish up and say questions. All right, so I've got one. Someone's already posted. If you want to post a question, feel free to post it. Or if you want to talk, please do that as well. I've got my Twitter handle there, my email if anyone wants to follow up later on. I would like to know your thoughts about deep learning with TinyML and also the rise of AI devices. Okay, this is a fantastic question, Rudy. So we've definitely seen things change, right? So when TensorFlow came out, there was no machine learning on devices, right? It was all in the cloud or on big, you'd have your big GPU, that kind of thing. We're now seeing a split between getting really, really big models in the cloud and then really, really small models for mobile and for TinyML. So TinyML generally means things like, maybe like a Raspberry Pi Pico, or even a lot of it's custom, hardware and smaller. I remember at Google one day, they gave us these things which were, I'm just seeing, do I have it here? I'm gonna guess somewhere probably, but anyway, all it was it ran a 10K model. So it was using a very small version of TensorFlow Lite, but TensorFlow Micro, for that. And all it could do was could hear if someone said hello. So that's what we call like a wake word detector. Right, so if you've got an Alexa or a Google or something where people go, hey, whatever, I don't want to turn off a bunch of devices, but that's how they're working, right? They're using a very tiny model on that piece of hardware, and then that turns it on and connects it to the cloud for the full stuff that you say. So when you do the wake word, what's called the wake word thing there, that's actually running local. The rise of these AI devices is huge. So we're seeing that like IoT devices are getting so cheap that like for sort of $3 to $5 US in bulk, people can get these devices and they can stick them around buildings. So they don't care if one of them breaks, right? They're all sort of hooked up and putting things in, and maybe they've got a sensor for, for air quality. Maybe they've got something like that. But they all bring back data, which then can be used to train models, and those, models can then be deployed to the edge as well. So we're seeing this idea of cloud versus edge. You're going to see the edge part get much more, that's going to explode even more in the next few years, because we're starting to see now some of these bigger models actually can be run on mobile phones and stuff like that. Google's working on a number of projects for very cheap mobile phones, but they're also very conscious of making these mobile phones so that they can run, deep learning models at the edge. If you know the sort of story for sort of TensorFlow and stuff like that, just to sort of, I'll tell you just a quick story, was that speech, right? Transcribing speech, or just, speech to text kind of stuff. Google realized that people were starting to use this. So the original versions of speech to text ran in the cloud. And Google realized, hang on a minute, if just everyone in the world does, everyone who's got an Android phone does this for 5 minutes a day, we're going to need like 3 or 4 times the amount of data centers that we've got, right? And that's when they realized, we better make this work on the phone, right? So actually there's been speech-to-text deep learning models in Android since, I think it's like Android 4 or Android 5, one of the very early, Androids. And obviously that's gotten much better over time. If you've got a Google device, there's an app called Recorder, which does amazing transcripts of stuff. And I think you can kind of hack it to work on other Android phones as well. But anyway, that's a different issue. So yes, I'm very bullish on TinyML. It's definitely a thing, and it's something that you can get involved with quite cheaply. Like I said, a lot of these devices you're talking about, like I think a Raspberry Pi Pico is $8 to $10, something like that. You're seeing more and more of these devices get cheaper and cheaper. All right, another question, Patrick. I would like to know how to participate in bigger project with other people. Is the easiest way to participate in an open source project? This is a very good question, Patrick. Okay, how do you get involved with other, with other things out there? Get on Twitter, right? If you're not on Twitter, get on Twitter and start looking around. Go along to places like the Hugging Face forums or the TensorFlow forums, stuff like that, and you'll see that lots of people are trying to work on different things. Like in Hugging Face, there's been a big movement, actually in other things as well. There's a big movement for people to do other languages of models that have only been done in English. So there's like an Indo-BERT model, I'm pretty sure, for Bahasa that was trained by people in Indonesia using, help from, people externally. So if you've got something that you want to do, get on there and ask people, hey, how do I do it? Who can help me do this? And you'll find that people probably will join in. Hackathons are a great place to go. Going along to a hackathon and just talking to people and, asking people, you'll find that the majority of the community, I would say, is very good if you're asking, smart questions, right? Always, any question you've got, Google it first, look at Stack Overflow, do your research. Don't ask something that's already been answered 10,000 times out there, right? But if you've got a question that no one's got an answer to, then ask, right? And people will often jump in. So I would definitely say get involved in the forums, get involved in some of those places, and look out on Twitter, because there's lots of projects out there that people are doing that is looking for people to work on open source stuff. That's something definitely. And the other thing you could do, like the internship thing is really big as well. Especially for those of you who are at university and stuff, I apply for internships, not just in Indonesia, right? Go and apply for internships, all around the world. We've had interns at Red Dragon, and we've given them, projects to work on, and they ended up with being the first author on a paper at a top, conference, because they ran with this idea that we gave them and turned it into something. And, that particular person has now been able to get into a PhD program and go on and study this, right? And they were just an intern that, that worked with us and stuff like that. Get your skill, your skills good. Oh, someone's posted the Google Summer of Code. This is, let me see if I can bring this up here. Yeah, okay, so this is Google Summer of Code. I think it's probably over for this year, but it's on a lot. So normally this is the US summer rather than Southern Hemisphere summer. There are lots of opportunities for this, and I can tell you that in Southeast Asia, Google wants to start doing these things more, right? So in the past, they haven't done these things in Southeast Asia as much, but definitely now, Google has, like, even just, if we're just talking about Indonesia, Google has a data center in Indonesia, which means they have to have staff there, which means there are opportunities for all these things. Google has a program internally called the Next Billion program, where the Next Billion Users program, and that Indonesia is one of the big focuses for that, of where they're looking to try and get users. So even if you don't get it going in to do ML, you could go in and maybe work on something else, but then bring ML along to the project, right? If you tell people, hey, I want to try and do ML with Android or something like that, people will find something for you to do. So that's one that I would say, yeah, it's definitely good. Any other questions? I'm conscious of that we've gone over time too, but if people have questions, the biggest thing I guess I wanted to sort of convey to you today is, don't be intimidated to think that you can't do this, because trust me that we're at this interesting point now where there's going to be this massive demand for people. There's by far not enough people that have these skills, right? Like I started off talking about the fake AI people. There's going to be a lot more of them, but we need, the real AI people. There's going to be jobs for that. And the thing is that for the implementation stuff, it's not an easy thing. So if you can put in the hours and get good at it, you will get job offers left, right, and center. I took, for a couple of years. So, I run, I run the company now and stuff like that. But for a couple of years, I took that down and I just put like ML engineer on my LinkedIn. And every week I would get a job offer of people, reaching out to me and stuff like that. And trust me, it's not that, I would love to think that I'm so good or something like that. And yeah, okay, maybe I've done well. I've had good publications and papers and stuff like that. But also it's just because there's just not enough people, right? That that people would reach out to you constantly looking to, to get you for particular groups and stuff. And I think going forward, you're going to see this more and more as well. Go for it. That's my biggest encouragement to you. Any other questions? If people want to speak, also go for, feel free to ask a question. Esther, are you here or who's running?
Yes. Thank you, Sam, for speaking at our event in Surabaya. Thank you.
It's a pleasure.
For your support for GDG Surabaya. So Sam is also my mentor from Women Developer Academy, and he gave me a lot of insights on how to speak and machine learning too. So I'm very excited that he can come today and speak at our event. Now we are going to have a quiz on your talk and also Ray's talk.
Okay, quiz on my talk. That's gonna be okay.
Yeah, so someone made the questions from your talk, and now you will see who is the best top scorer.
Okay, all right.
Okay, so Isti, you can take over from here.
Okay, thank you, Mr. Sam and Bu Esther.
Thank you.
Yeah, Mister, that's very interesting, Mister. So come on, friends, give a virtual applause for the speaker session 1 and speaker session 2, please. Okay. Nah, oke, kalau gitu kita langsung aja ya ke kuis. Teman-teman bisa join dulu nih ke kuisnya yang udah ada di box chat. Gitu ya. Sekarang waktunya kuis ya. Oke, yang join masih 8 nih, guys. 11, 13. Yuk. Join yuk. Nah, nanti ini kuisnya tuh bakalan dapat hadiah untuk 3 pemenang gitu. Yuk. Oke, share screen ya. Nah. Oke, share screen saya udah kelihatan belum? Udah kelihatan ya? Iya.
Belum,
masih belum, Kak.
Masih
Nah,
belum?
ini baru sudah masuk ini.
Oke, sip. Nah. Masih 15. Kalau udah nyampe 20 baru bisa saya start. Ya. Anyway, ada teks nih dari Mr. Sam. Thanks everyone, it was great to speak to you all and feel free to reach out in the future. Wah, thank you Mr. Sam. Masih 16 nih. Yuk yang belum join silakan join dulu ya. Ya, kurang 1 peserta lagi, nanti teman-teman langsung saya start nih. Masih 19. Kurang 1 lagi pesertanya. Ayo, 1 peserta lagi. Ini pesertanya ada berapa ya? Pesertanya ada 36 loh. Ayo. Nah, ini yang mau hadiah harus ikut kuisis dulu. Oke, kalau gitu langsung saya start aja ya. Oke, mulai kuisnya. Yuk, digas. Oke. Nah, siapa aja nih yang udah? Nah, oke guys, yuk. Silakan bermain. Wow, cepet-cepetan nih. 950 poinnya. Asik. Ya, siapa yang udah selesai? Oh ya, perlu diketahui kalau 1 soal kuis 30 detik. Jadi totalnya nanti 5 menit ya, waktu kuisnya. Aduh, kejar-kejaran nih. Ada Pak Marcel yang tiba-tiba ke atas. Wow. Alfredo. Nomor 1 nih. Seru ya? Yuk guys. Wow. Wow, cepet-cepetan ya. Oke guys. Perlu diketahui ya, kalau misalnya 3 pemenang terbaik akan mendapatkan hadiah dari GITS Indonesia. Nah, jadi ayo teman-teman, jawabannya harus benar dan tepat. 3 pemenang bakalan dapat hadiah. Gandalf, nomor 1. Wow, siapa tuh? RRR. Langsung naik ke atas. Harusnya tuh pakai nama lengkap gitu loh, biar nanti pas waktu pengumuman tuh tahu. Wow, tetap ya, Alfredo nomor 1. Wah, ganti. Mantap. Sekali lagi saya bilang ya, nanti 3 peserta yang menang dapat hadiah dari GITS Indonesia. Jadi jawabannya harus tepat ya. Oke. Wah. Mantap, mantap, mantap. Marcel. Waduh. Yang namanya Pak Prabowo ini langsung naik ya. Prabowo. Mantap, mantap. Wow. Nah, udah pada selesai belum ya ini ya? Oke. Oke, udah semua? Belum ya, masih pada ini ya, kerjakan ya. Seru nih. Nomor pertama, Marcel. Tadi nomor pertama, Golf. Wow, nomor 5 nih sekarang. Ayo guys, gaskan guys. Ya, ada yang turun ke 8 nih. Siapa nih? Mbak Indra. Waduh, kasihan. Ayo Mbak Indra. Oh, Mbak Indra udah selesai ya? Nah, ini berarti udah selesai semua ya? Langsung saya end ya kalau gitu ya. Apa belum?
Kayaknya Prabowo belum selesai itu. Segera milih. Segera milih. Kurang satu pilihan itu.
Ayo. Wah, ini juga ada nih, Muhammad Faisal. Belum selesai juga. Wah, banyak yang belum selesai ternyata ya. Ayo, kurang satu pilihan nih. Prabowo. Ya, alhamdulillah udah selesai ya. Ini udah selesai semua ya berarti atau gimana? Bu Esther?
Ya, sudah. Oke.
Sudah.
5 menit kan ya?
Iya, udah 5 menit. Saya end ya kalau gitu ya.
Oke.
And yes. Nah. Oke, berarti pemenangnya jeng jeng. Ya, pemenang pertama yaitu Marcel, kedua Prabowo, dan ketiga Good. Nah, Good ini siapa ya? Oke, saya screenshot dulu lah.
Memenang screenshot layarnya ya.
Saya screenshot dulu ya. Nah, oke.
Boleh raise hand yang menang.
Ya, yang menang raise hand dulu guys. Izin stop share screen. Marcel, terus tadi Prabowo ya kalau nggak salah, sama Good. Oh, Arya bagus. Oke. Nah, oke, udah ya, berarti ada Marcel, ada Arya Bagus, dan Prabowo Yoga. Nah, nanti yang menang ini harap kontak ke Mas Re ya untuk mendapatkan hadiah gitu. Nah, oke, kalau gitu teman-teman, pada saat ini kami minta bantuannya untuk dapat mengisi form feedback. Nanti setelah mengisi form feedback, teman-teman bakalan dapat sertifikat ya, sertifikat. Jadi teman-teman dapat link-link yang akan dibagikan. Nah, itu sudah dibagikan sama Mbak Jacqueline. Gitu teman-teman. Nah, kita juga ada sosial media ya. Jadi yang tadi sudah saya sampaikan, minta tolong dari teman-teman follow Instagram dari GDG Surabaya dan GDG Bandung. Nah, nanti di sini bakalan ada challenge nih teman-teman. Saatnya juga cukup mudah, yaitu follow Instagram dari akun kedua tersebut. Nah, kemudian jangan lupa jangan private akun Instagramnya ya. Terus setelah itu sampai hari ini kalian juga bisa snap your best moment and upload moment tersebut dengan Twibbon yang udah di Nah, yang udah dikirimkan oleh Mbak Jacqueline. Gitu, teman-teman. Nah, jangan lupa tag GDG ya nanti ya, GDG Surabaya dan GDG Cloud Bandung. Nah, supaya kita bisa lihat dan repost kontennya teman-teman. Jadi semuanya yang repost akan mengikuti lucky draw dan satu orang yang beruntung akan memenangkan voucher tiket.com untuk healing teman-teman. Nah, gitu ya teman-teman. Nah, oke, baiklah teman-teman. Sekarang kita foto bareng-bareng dulu ya untuk dokumentasi. Gitu, bentar ya. Oke, semuanya jangan lupa open cam dulu ya. Open cam dulu semuanya. Jangan lupa pakai virtual background yang udah dikirimkan tadi ya. Oke. Oke, udah pada ini ya, on cam. Kayaknya masih ada yang belum on cam nih. Ayo dong teman-teman on cam. Nah, gitu. Oke. Saya screenshot dulu ya. Bentar. Ayo semuanya. 1, 2, 3, cheese. Oke, lagi. 1, 2, 3, cheese. Mas Rey lucu. Oke, yang satunya. Oke, lagi ya. 1, 2, 3, cheese. Oke, yang satunya. Udah selesai nih ternyata. Oke, kalau gitu udah selesai nih teman-teman. Kita udah di ujung acara. Baiklah teman-teman, dengan berakhirnya acara ini, saya atas nama pihak penyelenggara ML Study Jam 20 and 22 mengucapkan terima kasih banyak kepada pihak GDG Cloud Bandung yang sudah berkolaborasi dengan pihak Google Developer Group Surabaya. Nah, terima kasih juga kepada seluruh peserta yang sudah berkenan hadir dan panitia dari GDG Surabaya dan Institut Sains dan Teknologi Terpadu Surabaya yang sudah menyiapkan acara dengan baik. Nah, akhir kata, semoga acara ini boleh dapat mendatangkan manfaat untuk kita. Amin. Mohon maaf apabila ada salah kata atau perilaku yang kurang berkenan ya, teman-teman. Semoga kita semua dapat bertemu kembali di kesempatan mendatang. Nah, oke, semuanya selamat malam. Ya. Semoga sehat.
Our world has changed so much since I was a kid that things that I want to do now weren't even possible for me to imagine.
I don't even know if I knew it was called computer science or programming.
It all sort of happened by accident.
I was always excited about technology in some way and people.
And I thought that was just really neat to be able to control the technology instead of just having it control you.
I think a lot of people wake up and they have an amazing idea. When you know how to